All right, thanks everybody for showing up today on a Friday. I know it's a little challenging time. This was kind of the best time, least bad time that worked for everybody on the presentation side. So we appreciate you taking time out of your Friday. I know for some folks on the East Coast, it's kind of the last thing you're doing Friday afternoon. Folks on the West Coast, especially at JPL, it's a regular day off. So for the JPLers, thanks for taking time from your kind of normal vacation day or whatever. And again, just welcome to everybody that's online. I know we have folks from morning time zones all the way to late evening. Betsy is in Europe and Rashmi is in Indonesia. So folks are all over the place. So welcome to our mini symposium on leveraging commercial and nonprofit satellite capabilities, plans, and opportunities for Earth system observation continuity. A little bit of a mouthful, but as we were just talking about, we think it's a pretty timely topic and wanted to spend, we think we're going to have a great 3-hour conversation today, or up to 3 hours, might not take the whole time, conversation today on this. This virtual mini symposium is co-sponsored by the JPL Center for Climate Sciences and by the Keck Institute for Space Studies in conjunction with a 2022 study developing a continuity framework for satellite observations of climate. I'm going to talk about that a little bit more as part of the intro section to make sure everybody kind of understands the context for today's set of talks and discussions. The mini symposium is being recorded in case you haven't noticed. And the two websites below, both KISS and the Climate Science Center at JPL, will have host information, both slides and the recordings. So if you want to reference the material afterwards, you can go there. And I'll show you a timeline in a minute. There are some past talks that you can go to. If you want to look at the past talks kind of in this series, you can go to those websites and catch the recordings. So let's see, for the topic today, we've got 5.
Can I make one interruption? Sorry.
Yeah.
I'd just like to say on behalf of the Climate Center, Joao Teixeira, say thanks to Joao and Graham for helping host this. Joao was one of those predefined commitments, personal commitments, so he couldn't be here today. Graham did write me and say that he's going to join halfway through the seminar or the symposium. And I also wanted to call out the support by Wingsy and Margaret and Michelle Judd and Janet Said of Keck, who really helped put a lot of the stuff behind the scenes. And Daniel well knows that, and I just wanted to call that out. Thanks, Daniel.
Right. Yeah, no, thank you, Dwayne. Thanks for jumping in with that. Okay, so this is a rich and dynamic topic, right? We understand that our virtual mini symposium consists of a short intro that I'm going to hit. We've got 3 invited presentations that will have a substantial amount of kind of back and forth conversation as part of each of them, we think. And then we're going to close with a dedicated moderated discussion, right? So kind of just walking through these in order. As I indicated, I'm Daniel Illuminati. I'm the Chief System Engineer for Earth Science at JPL. Dwayne, who you just heard, is the Directorate Scientist for the Earth Science and Technology Director at JPL. And Betsy Weatherhead is also kind of helping co-organize this mini symposium. She's retired senior scientist from the University of Colorado, now at Jupiter Intelligence, and has lots of other side activities with WMO and other things kind of going on. So we'll hit this intro. After that, Asal Nasseri and Pat Patterson from the Space Dynamics Lab will talk about the historical evolution, current landscapes, and future plans of Earth observations by NGOs. And we use the term NGO here to mean commercial and nonprofit, right? So truly non-governmental entities of all kinds, both those that are trying to make a buck and the nonprofit variety, which are starting to spring up. So Asal is the branch head of satellite technologies at Space Dynamics Lab. Pat, who helped put the material together, but I think he's got conflicts today. He may be able to make it, we'll see. Is the Director of Advanced Concepts at the Space Dynamics Lab. So we really appreciate them being here to give that nice introductory talk. Kind of sets the foundation for most of the conversation today. And then we're going to jump into discussing strengths and challenges of NGO data relative to this continuity objective, climate variable observations. And that'll be Betsy, who I introduced already, and Jeff Privet. Jeff is the Deputy Chief of the National Center of Environmental Information at NOAA's Climate Science and Services Division, and we're really privileged and happy that he's joining our study team and able to talk today on this topic. And then topic number 4, Jeff will lead with Betsy and Chris Ruff supporting. That's going to be focusing on climate monitoring research topics that we think are addressable with NGO data sets, give some context of that, looking at ECVs and other kind of other angles of how you assess, climate observations. Chris, who I haven't introduced yet, is the Frederick Bartman Collegiate Professor of Climate and Space Science at the University of Michigan. He's an advisor to Muon Space, one of these new space entities, and he's the PI of the NASA Cygnus mission, which is a small constellation mission. And then to wrap, we'll have a moderated discussion with Rashmi Shah and myself helping run that. The focus of that moderated discussion will be kind of talking about civil space, how can and should civil space agencies respond to and take advantage of these NGO capabilities that you will have heard about in sections 2 through 4, with their strengths and weaknesses, et cetera. So, and Rashmi is also at JPL in the Earth Science Directorate. She's the Associate Technologist, and she's also the JPL project lead for the NASA SNOOPY technology demonstration mission. So that's kind of the broad brush of what we'll be hitting today. We have like roughly half an hour, time slots for each of these, and up to an hour or more at the end. As you see, it's a 3-hour slot today, but because the topic is so dynamic, we're going to allow a decent amount of back and forth conversation, both during each of the presentations and obviously at the end in the moderated conversation. So we're going to be flexible on time and just kind of play it by ear on what if the topics are starting to peter out and we need to make sure we got a little time for the next topic. So that's how the flow is going to go. So next, I just wanted to go into context, like how does this mini symposium fit into some other activities that are going on? So as you heard, this mini symposium is one of a few activities related to this KISS study. The Keck Institute for Space Science has a study focused on developing a continuity framework for satellite observations of climate. And I'll hit on the goal, expand on the goal of that study in a minute, but that study consists of a full week in mid-August where the study team of roughly 25 people will be gathering and spending, like literally 40 hours together in the same room, working through activities associated with the study goal. There'll be a follow-up KISS study, another week-long activity at Caltech later in the summer or early fall. Then that activity will kind of write a report and submit a report by roughly the end of the calendar year. And leading up to this KISS study are a few different mini symposia, right? And these are intended to both provide boundary conditions and inputs for the study to kind of get some of the business taken care of ahead of time, on relevant topics that you'll hear about in a second, and also provide an opportunity for the study team to actually get to know each other, right? A lot of us haven't worked together before. And so organizing these symposia kind of forces us to coordinate, get together, and get to know each other a little bit so that, a little bit of an icebreaker ahead of being stuck in a room together for 40 hours in August and later. So the first topic that was covered that was directly related to the study was a mini symposium back at the end of June that Stacy Boland and company ran. And that covered the International National Satellite Program of Record and plans on continuity. And this focused really on civil space agencies, right? What are mostly European and US, but also a little bit of Asian, Japan, civil space agencies. What are they planning in the realm of climate observations? So to complement that, we felt it was important to also talk about the commercial sector. So that's today's mini symposium, right? What are the commercial capabilities, plans, and opportunities that impact the program of record and plans on continuity, again, with for climate observations in particular, right? That's the context. So we'll be spending time on that today. There's a bunch of other activities that we're tracking, right? There was another Climate Center talk earlier in April on the essential role of long-term satellite observations focused on climate and radiation monitoring. You see coming up here in September, there'll be another Climate Science Center long-term satellite record discussion on oceans and climate. That's also going to be relevant to our overall KISS study activity. Many of you may be aware, I just wanted to highlight, right, a NASEM study on leveraging commercial space for Earth and ocean remote sensing came out in March. Chris and Pat and others were on that report. And Chris is going to highlight a couple of the key takeaways in section 4 of the conversation today. So we're aware of those other activities, and we're going to try to tell you a little bit about them in the context of the conversations we're having today. And then, the other thing you see at the bottom here is obviously we've got the decadal survey related activities, both the midterm review for the 2017 decadal survey for Earth Science and the upcoming 2027 activity. And so we're kind of hoping the report output will feed into those activities a little bit or be useful. And that's what this hits a little bit. So again, the goal of the broader study, right, that the mini symposium is part of, is to help accelerate discussions and plans for a greater and more impactful U.S. contribution to the global climate observing system, right? So we know NOAA has contributions here, NASA has contributions there. You know, maybe things that can be improved across the board a little bit, you know, for some of the variables, and we're hoping to facilitate that conversation. And you can kind of see the context again below relative to the midterm assessment of the last decadal and the planning activities for the next decadal. Right? So we're trying to be feeding into those activities with the report output. And Dwayne and Betsy, anything else that you want to add here that I might have missed?
No, I think you did that beautifully. I like the framing this in terms of there's an entire long set of conversations going on, and this is an important contribution to part of that.
Yeah. Yeah, thanks, Betsy. Again, yeah, big picture, there's definitely a lot of things. I'll hit that again in a second. Okay, so a little bit of the framing, and thanks to Jeff and Chris for helping kind of think about this way, right? So the presentations you're going to hear today are trying to hit a few different angles, right, of this topic, right? There's kind of a could element, right? Could, are NGOs contributing, or could they contribute to national, international climate observing goals? Should they, given the strengths and weaknesses? And we want to have a dialogue with, you know, with the audience on that topic. And if so, kind of what's the best way to incorporate them, right? So that's all of the presentations and trying to help us kind of cover these points today. So just make sure that's kept in mind. And then, and sorry for the background noise here, I'm on vacation. Like a lot of the people the times are not perfect. I'm like in a cottage with 15 people. So hopefully cut me some slack a little bit on the background noise. So the conduct for today, right? As I think we've mentioned multiple times, you know, this topic of NGO contributions to climate observations is rapidly evolving. You know, it's been kind of on the uptick in the last 5 years or so. And as Betsy said, you know, before we started at 11, everybody expects it to change probably dramatically in the next 5 years and beyond. And so we recognize this is a dynamically evolving topic. So keep that in mind, right? Today's presentations are just capturing kind of a snapshot of where we think things stand and where things might be. And we expect significant dialogue during each presentation and of the mini symposium, and you know, again at the end, right, in the moderated conversation. So that's all I had kind of for introductory material. There's a little bit on ground rules. So a little bit, if you're not familiar with WebEx, you know, everybody kind of has their favorite tools, whether it's Zoom or Microsoft Teams or WebEx. You're obviously using WebEx today. So it's just a little bit of etiquette and how to, like, what buttons to push in case you're not familiar with that. Thanks to Rashmi, by the way, for putting this together. So most of you your user interface should kind of show this participant button on the lower right hand. So if you click that button, you see this participant panel should pop up. And if you want to raise your hand to speak, right, we'll be kind of monitoring for raised hands, Rashmi and I, and we'll ask you to speak if you raise your hand. And that's where the raised hand shows up. If you want to check the chat, right, there is a chat that you can share with everybody. You can click this little kind of comment window chat button, and it'll open up another box. I didn't show it here. That's the chat box. And so if you want to ask questions, you know, you can also just type in there, and then we can kind of read those out loud and get them asked and kick off a conversation that way, if you're more comfortable doing that. And then we did want to make sure everybody's muted, you know, on the audio side. So unless you're actively speaking, make sure that you're muted. That's the button here. If you are presenting, usually the button's up here on the screen, right? That looks a little bit different if you're presenting. And I think that's basically it. So any questions on the intro before we move on to the first topic? Okay, if not, then I will stop sharing. I will mute myself and we'll hand it over to Asal.
I hope everyone can see the PowerPoint slides in presentation mode. Great, thanks, Vinci. Hi, everyone. My name is Asal Noseri. As Daniel mentioned, Pat Patterson and I we work at Space Dynamics Lab. Pat was the one who put most of the slides together, but unfortunately, he had other engagements, and he's also the chairman of the Small Satellite Conference, which is only 3 weeks away from us, and he has been really busy with that. But what we wanted to talk to you about is to bring everyone on the same page as where we are when it comes to non-government operators, when it comes to remote sensing, Earth observations, environmental observations. So we will give you a quick background on the historical evolution, and then the current landscape and future plans. So space has been becoming more global since 1966, when we had the first commercial satellite operator. We had only 6 countries with satellites on orbit, to 2020, where we have more than 70 countries with mostly small satellite, but satellite capabilities and satellites in space. Space has been becoming more commercial. So as I mentioned, in 1966, AT&T was the first and only commercial satellite operator. Whereas in 2020, we had more than 130 commercial operators. Some of them you see here, these are the ones that have at least 5 small satellites on orbit. And we know when it comes to commercial companies, new space companies, there's always a chance that they may not make it or may go out of business. But usually, if they have more than 5 satellites on orbit, they know what they're doing. So you see that here in this case, SpaceX, Planet, Spire, OneWeb, and they were the major players, but there are all those other companies out there as well. And this growth in not just the number of countries becoming, the space industry becoming global, but also commercial companies, the number of commercial companies increasing, is because of the small satellites. So as you see here, in the past 11 years or so, this is what this chart is showing, the number of small satellites, and everyone, we have different definitions for small satellites. Sometimes it's less than 500, sometimes it's less than 1,000 or 1,200 kilograms for the sake of this chart. And the rest of the charts, let's assume that when we talk about small satellites, it's anything less than 600 kilograms. And you see from 2011, where we had maybe 10 small satellites on orbit, out of the about 1,800 total satellites launched in 2021, 94% were small satellites. And here is you see from the 57, if I'm not mistaken, when Sputnik was launched, to all the way to 2020, and later on what has been launched before and what's going to be launched in the next decade or so. So over the next decade, nearly as many small satellites are expected to be launched as all the satellites since the beginning of the space age. And so this rapid growth in small satellites are mainly because of those commercial operators where they have now, they are planning or have already put constellations of operational satellites in space. So let's talk about what's happening right now. Here you see the estimated number of operating commercial remote sensing satellites, both US and non-US international companies, from 1995 to 2023. As you see here, in early 2020, there were about 225 commercial remote sensing satellites on orbit compared to about 25 in 2010. And this tremendous increase, remarkable increase in the number of satellites within a decade is mostly because of all those small sat companies, constellations, and a Planet Labs Dove constellation is a big contributor where they started the launches in 2014. And the estimation that you see here, the forecast also includes those companies that have not flown all their constellation satellites yet, like Black Sky and Capella. And then here, I want to talk about the new commercial companies or constellations. So the new entrance to the commercial space-based remote sensing market has been driving a change in capabilities. You see in this chart, the revisit rate, basically temporal resolution, spatial resolution, and the phenomenologies that for these current commercial remote sensing capabilities and constellations. Up top on the chart, there in the blue oval are those new constellations with initial launch in 2014 or later that, as you see, they have varied spatial resolution, and the spatial resolution can be coarse because these are mainly smaller satellites, maybe less capable, but the technology is still improving. And even the spatial resolution is going to improve in time. But when it comes to revisit rate or the temporal resolution, the increased rate is because these are larger constellations of smaller satellites. And as you see, we have panchromatic multispectral imageries, as well as radar, SAR, and hyperspectral phenomenologies. And these were, up until recently, rare. SAR and hyperspectral were rare in the commercial market, but now we see more growth with companies like Capella that is developing X-ray radar, and other companies. We are seeing these capabilities in the market too. But the one thing that I want to note here is that the older, let's say, or established commercial companies like Maxar that acquired Globe Digital, so the GeoEye and Worldview are being operated by Maxar, and these are larger spacecraft in geo platforms, have the capability for tasking, queuing, pointing, but most of the other constellations, the small sat constellations, don't have those capabilities. Here is just a summary of some US-based commercial providers. Maxar and Planet are two of the more established ones. Maxar right now has 3 large satellites, part of its Worldview constellation on orbit. Originally there were 4, but the Worldview 4 failed on orbit in 2019. But you see here that they have a minimum revisit time of 1 day, and you can see the phenomenology and the spatial resolution capabilities. And Maxar is planning on launching 6 spacecraft as part of its Worldview Legion constellation that have been, the launch now has been delayed actually to September of 2022. We'll see if they will actually get launched then or not. But they are planning then with these 6 to have basically 15 visits per day. And then we have Planet or Planet Labs that was founded in 2010. They are now operating 2 fully operational constellations, Dove or PlanetScope and then SkySat. And then the newer companies, we have Capella, Black Sky, Hawkeye, and HiSpec. As I mentioned, Capella has the radar capability, and it actually right now, these are all these charts, we got them from the RAND analysis report that is a couple of years old. So Capella actually has now 7 satellites on orbit. And then Black Sky currently has 14 operational satellites and planning to launch the rest on a frequent basis, basically. And Hawkeye is the first RF constellation, commercial constellation on orbit that has right now 3 clusters of 3 satellites and plan to launch more. And then HiSpec IQ, they are planning their first launch in 2024 for hyperspectral imaging. And as you see here, you have the phenomenology, the spatial resolution, and the temporal resolution information for those companies. When it comes to environmental monitoring, the commercial market hasn't grown as much as remote sensing Earth observations, mainly because of the uncertainties in the market, in the sense that they, other than NOAA and DoD, they haven't been able to establish a customer base, and which makes it harder for them to have a foothold in the market. So the major or the biggest developments have been in GNSS radio occultation companies. And you see here, Spire Global and GeoOptics have already established constellations, operational constellations on orbit. Whereas Planet IQ currently has only 1 satellite on orbit, planning to launch the about 19 other spacecraft by 2024. The 2022 is also out of date because of the date this report came out. But as you see, so NOAA set a goal of wanting 20,000 radio occultation profiles a day, and this is the current capability for 5,000 per day for Spire, but with they are actually have plans to increase those soundings to 20,000 or more, Planet IQ to 15,000 profiles per day. Now, the first 7 slides, which I'm not going to go into too much detail, are on the different satellites, small satellites, larger satellites like the WorldView ones, and constellations, their information on the bands, as well as their orbit and the number of spacecraft that are currently on orbit, or if they have any planned launches in the future. And most of the information comes from these 2 websites, Apollo Mapping and Sat Imaging Corp. And you see here that these are both US and international companies, like Jilin is from China. You have the different smaller one basically satellite versus constellations, and you can find information on these. This is the amount of information we actually found, because it's commercial companies don't give out too much detail, but and as you see, there are a fairly good number of companies that give information, but some starting about here, as you see in this chart and the next, don't really give out information on the bans or what they plan to do. But we're hoping that as time passes and they actually establish more capability or a foothold in the market, they will actually provide more information to us. And then finally, we wanted to end this for now with some things to consider. That when it comes to these commercial or non-government systems, operators, you have to remember that the way they do calibration is very different from what the science community is used to saying, if they have to actually perform any calibration. And then there is the lack of cross-calibration between constellations. There is no information and there is no way to do that. And then the last one is long-term stability of the data and the quality of data that's being gathered. So most of these operational constellations are small satellites, which means that they have a limited lifetime on orbit. And as the operator puts or launches more spacecraft to replace the ones that have deorbited or have failed on orbit, the quality of sensors on the spacecraft may change, which actually the new generation will probably have more capability. But also, as time passes, these there will be degradation in the quality, in the performance of the sensors, but we really don't know if those companies can actually give more detail or have more detail on how the performance degrades over time. So the long-term stability is another thing to consider. And but still, there is valuable information here that we think should be used to augment those large government programs and satellites that are currently on orbit or are planned to go on orbit. Not replace those, but actually use these constellations for augmentation of information and accessibility to more data. So these were the slides that we provided. I can stop sharing to see if there are any questions.
I think Dwayne, that was great. Thank you very much, Asal. That was a great presentation. Dwayne had a question. Dwayne, do you want to ask yours?
Oh, sure. I Sal, thank you for that. I just noticed in one of your commercial companies, their seemingly purpose was RF detection. And I wasn't sure what the commercial purpose or sponsorship. And Daniel, I think, probably gave a good answer, but I was kind of curious on what yours would be.
These are the commercial companies. Some of them only have customers in DoD. Okay. Or I can see actually, yep, you're right, Daniel answered it perfectly. Their customers are on the NRO DoD side rather than civil or commercial side. So the charts I showed that you will also have access to, the ones especially on the RAND analysis are mostly focused on what is needed or the interest of the intelligence community rather than the science community.
Thank you.
Sure.
Okay, before we move on, does anybody else have any other questions for Asal?
This is Dallas Masters from Yuan Space. Can you hear me?
Yep, we can hear you.
I just have a comment about the slide 20, with the assertions that commercial data from commercial satellites are different than, say, government satellites, or don't have cross calibration or have issues with long-term stability. I think that commercial satellite companies follow typically the same types of development processes that government satellites do. The data that they're generating are also calibrated against other sensors, usually larger government sensors that are higher quality. And I think that as well, the stability of a sensor in some senses depends on the type of sensor that you're flying. In the case of GNSS radio occultation, those sensors actually don't have stability problems because of the nature of GNSS RO. And as well, the companies are trying to put out enough information and supply low-level data such that you can, users of those data sets can judge the quality. I do think that there are issues with communicating the changes that happen over time. But if a company changes its sensors, but I think that my experience has been the companies are trying their best to give out that type of information to users like NASA and NOAA and others. So I just want to make that comment.
Those are really good points. Thank you.
And I think we're going to delve into that a little bit more in the next couple sections as well. So I'm sure we're going to talk more about that. Anybody else have any other questions or comments in this section before we move on?
Daniel, are you watching the raised hands? Because I have my hand raised and Eric DeWeaver has his hand raised.
Oh, thank you.
And
Thank
I
you very
can't
much.
raise my hand, but I have a question. Okay.
Yeah, so see, I didn't catch who went first. So maybe Eric, why don't you go first?
Thanks. So this is a great presentation. I'm really learning a lot from it. One of the things that's on your slides is, you mentioned commercial satellites as augmentation, but I think we have to be a little bit careful about the word augmentation because, NOAA is operating under the Weather Act, and the Weather Act more or less mandates NOAA to purchase data rather than launching its own satellite. So I think we've gone beyond augmentation in this case. And I think, one of the things that, we've never really worried about before is requirements for climate observing. When people launch satellite, they do the best they can and they, try to make an all-purpose satellite. Whereas when NOAA purchases data, they go by a list of requirements, which I believe is more or less entirely determined according, by the value of that data for 5-day weather forecasts. So you worry about things like latency, you worry about, to some extent, signal to noise and this, that. But there are no requirements that specifically speak to the use of that data for climate observing. And I think there could be. I mean, you could make a requirement, for instance, that the data has to be shared the way it would be if this were a government-launched satellite. You could make requirements about quality control, things like that. So, I wonder if you've given that kind of consideration that, this isn't just about augmentation, but how do we kind of, think about the requirements and needs of climate observing when we purchase data?
Those are excellent points. And I just have to say something. Pat and I put that slide together to generate discussion and conversation, and I think we succeeded. So one thing we were, that augmentation we were thinking of were based on the existing small sat constellations. And you are correct. So if NOAA actually goes and buys data that satisfy their requirements, that's perfectly great. That is what we want. But we wanted to put a note of caution there that most of these may not satisfy the requirements. That's why augmentation rather than replacement. And they were, at least the existing companies, they were not, well, let's stop right there. But yeah, those were really great points.
Okay, thanks.
Can I just interject a little bit? These questions are great, and it looks like a great, sort of participant list. The first time anybody enters a question, if you don't mind sort of telling introducing yourself so folks know the varied backgrounds that we have. I know Eric, for example, you're from National Science Foundation. Thanks for joining. And anyone else, if you could just let people know where you're from, it'd be great. Thank you.
I can, this is Dallas Masters. I am at Neon Space right now. And I was formerly the head of Earth observations at Spire Global.
Daniel, you there?
Great. Yep, I'm here. Thank you. Okay, and I think Elizabeth, you had your hand raised still. So I'm going to give this another couple minutes. I think so far the questions substantially land on topics 3 and 4 on the agenda, and so let's see if they keep going that way. I'm going to then kind of cut things off if they keep going in that direction, and then we can wait to have those, like, have more detailed conversation when we let Betsy and Jeff and company get through their stuff. But go ahead, Betsy. Let's see, Betsy, you're muted. I don't know if your hand's still up or not.
So sorry.
It's okay.
Dallas covered my points pretty darn well, so I'm happy to take my hand down.
Okay, thanks. And then in the chat, let's see. So Tim Stryker makes a point in the chat. May not be up to date, but Tim, why don't you just raise your point if you think it's still relevant here?
Thank you. This is Tim Stryker. I'm at U.S. Geological Survey. Also involved earlier in the licensing of commercial remote sensing satellites, managing that program at NOAA some years ago. And I do recall at the time, the Land Remote Sensing Policy Act specifically prohibited the commercialization of weather satellites. And unless that's been repealed, I think that still stands. Although that certainly does not rule out, the ability of there to be a mix of public sector and private sector weather observations to contribute to, NOAA's ensemble modeling and forecasting services. And so certainly there's more and more commercial data available, and I'm aware, of NOAA's purchasing and use of these data. But I would be a little cautious. I think there still is a lot of room for foundational public good civil Earth observing systems operated by NASA, NOAA, and USGS that will be augmented by tremendous commercial capabilities, especially once those capabilities are more closely intercalibrated and the data become, more ingestible and usable in the models and products and forecasts. Thank you.
Great, thanks for that point. So I'm going to go ahead and ask Anthony and Charlie to maybe hold your questions since we are about 30 minutes into this talk now. And why don't you see how the next 2 sections go, and then raise your points there if that's okay. So let's transition.
That's okay. It's okay, but it is kind of technical about this particular talk.
Okay, that's fine. Go ahead.
I don't see the speaker, but anyway, yeah, it's a question and a comment.
So Anthony, can you introduce yourself? Where are you from?
Yeah, I work at JPL. Okay. Okay, the question for the speaker is, or the comment, I guess, kind of comment is reconciling the very high spatial resolution and the revisit time in normal NASA and normal climate monitoring. It's just a matter of swath, the smaller your pixels, the smaller your swath, and that determines how long it takes to come back. Your numbers don't work that way because your satellites are tasked to look back at something usually from an oblique view, right? Am I correct? Yeah.
So Anthony, I'm not sure if I understand your question about when you say your satellites.
Okay, I'll rephrase. You stated systematically the size of the pixels, but never the size of the swath.
Because that was all the information that was available to us.
Oh, okay. Well, the reason, okay, they look at, say, a meter scale, and they look at a few kilometers. But if they're always just looking straight down, as we do at NASA satellites typically, then there's no way you can come back every day.
Well,
Typical
so the other
revisit
thing,
time.
This
Go ahead,
is,
Asal.
now I understand, sorry, Daniel. We are talking, these depends on whether you have one spacecraft or a constellation.
That's true. Okay, that's true.
And most of these, so that were in the slides, those especially constellations are in sun-sync orbit. So they are covering the whole globe if depending on the ascending node. And yeah, depending on the, especially the revisit times, the temporal resolution is based on the number of spacecraft in the constellation.
Okay, so you're saying they are typically nadir looking.
Yes.
Okay. That brings my other question is angular pointability, tasking. You know, can these satellites be tasked to slew over and look at things from a side?
So I want to say, I'm sure all of these constellations, they have the capability, but that information at least wasn't available to us or in the RAND analysis. They are not readily available information for and we are talking about, again, those small satellite constellations.
Yes, because that would be very interesting for us in
Yes.
climate, to see things from different angles for a whole bunch of reasons I won't go into, or except maybe later. Thank you.
But,
Okay.
yeah. Okay.
Thanks, Anthony. Okay, I think we need to move on. So if Betsy, I think you're up next, you and Jeff. So I think we can say you're going to share your screen here for Betsy.
Great, thanks. So Jeff and I are trying to tee up this conversation in terms of strengths and challenges for NGO data. Next slide, please. And this is roughly what we're going to cover. The scientific challenges, I think we have to keep that in mind. I think it might have been Eric who mentioned that we didn't yet have clearly stated requirements for climate data. I think we might, but let's set that aside for the moment. Then we're going to just summarize the challenges as we saw the current, the strengths, the challenges, and then a little bit on the current activities. Our intention here is for everyone else to augment what we've written down so that we can, as a community, be more clear on what we feel the strengths and the challenges are. Next slide, please. Oh shoot, we're gonna have to just keep clicking. Sorry about this. I probably should have sent, yeah. So this is a plot of the time series of surface temperature data for each of the main continents, and then the dark solid one is for the oceans, showing that what we've been seeing over the past is a lot of increase in climate trends, and that has been the focus for climate science quite a bit, is documenting the trends and the accuracy needed in order to document very small trends of often roughly 0.2 degrees centigrade per decade is challenging in and of itself on a global level. Next slide, please. But previously, therefore, our motivation has really been documenting the change in many parameters and many locations, as well as examining the impacts. But as we go forward in climate science, it's not just all about trends. I think what we're going to be looking forward to is documenting changes to change, meaning changes in the trends that we have observed, which is a whole new set of challenges for us. There's also a lot of climate science that's focused on predicting extreme events and being prepared for those. We continue to examine impacts. And then there's also, I believe, evaluating mitigation efforts, particularly nature-based mitigation efforts, as well as estimating economic impacts. So the number of needs that we're going to be addressing with our climate data is changing from what it has been in the past. And because of this, I think that we have to evaluate the strengths and challenges of private satellites within that context. Next slide. So in terms of documenting changes, I showed you this just already. Can you go ahead and hit spacebar on that one? And so we have been looking at just documenting the increase in trends, but we might, as some of the climate models are showing us, we might see an increase in projected temperatures. And if that's the case, based on some of our CMIP models, we want to be able to know that we're on one of that expedited trajectories. Next slide. We can also, if one wants to be optimistic, be not just looking at continued warming. Next, go ahead and hit the space bar if you would. We might be seeing a decrease if our mitigation efforts are strong enough and aggressive enough. And being able to detect that is also going to be one of the responsibilities of us in the atmospheric science community. So these are incredibly rigorous requirements that we have, backing up Eric's point in the question section for the last talk. Next slide, please. So I want to just identify at least some of the strengths that we've already pulled together here. You know, there are multiple funding sources if we embrace the NGO satellite observations. There are a lot of satellites that are addressing issues. For instance, the radio occultation satellites that are addressing weather issues, or there are satellites addressing communication issues or surveillance issues that could also be of use to us in the climate community. So there are a lot of funding sources that may not be directly applied to climate, and yet the data can be useful to us. So to me, that's a strength. I think our previous presenter really did a great job of showing how there are growing capabilities and activities going on in the NGO sector for satellite observations. And it's really our responsibility as scientists to make the most out of all possible capabilities and activities as they go forward. Private sector will be often quick to point out that they are willing sometimes to absorb the risk and then only do a data selling agreement, so that might actually be very advantageous, whereas the US government or other funding sources won't have to put all the money at risk for particularly new developments in instrumentation and observing approaches. We can specify the criteria that we need. The essential climate variables all have stability requirements. They have spatial, they have temporal. So we can specify the criteria and allow the private sector component or components who can come up with the most effective solution, as long as they meet the requirements, let them step forward and offer the data in that sense. So there are a number of ways in which this can be cost effective. Private sector is very good at doing things in cost-effective ways, getting things out the door as quickly as possible while still meeting requirements, because their income is dependent on meeting those requirements. Their acquisition costs, speed, agility, flexibility of space architecture, as well as leveraging a lot of NGO resources. In my current position, I do also want to say that I work for Jupiter Intelligence and we have no interest in observation. So please, there's nothing in it that's self-serving for Jupiter here. But I am now aware of all of the NGO resources who are interested in getting into the climate community, particularly philanthropic organizations. And when it comes to getting into the climate community, many of them are really interested in observations, in funding observations. They feel like that's a legacy gift to the world. So if we can embrace appropriate ways to do this, I think it's more appropriate for philanthropists to give money to a private sector entity to put up some satellites that give us critical information. That's more appropriate than them giving it to the federal government or even trying to do that. Next slide, please. Jeff, do you want to cover the challenges? This was more fully developed by you.
Sure. Can you hear me?
Yep.
Okay, thanks much. Yeah, thanks, Betty, and appreciate you going through all that. Yeah, so some of the challenges, and these are sort of just off the top of my head, not necessarily coming from any sort of research or great reading on this. But as NOAA has been looking at increasingly doing data buys and not sort of building planned out buses to do sequential buses, which would provide some continuity in instrument design and so on. I've been increasingly sort of concerned about this one, which is the requirements would have to be adjusted to what the real need is. Simply stating things like temporal resolution, spatial resolution, latency, and so on will not be good enough because you could have very different designs, signal noise issues, analog to digital convergence, and so on, which are going to give you things that create discontinuities. And every time there's some sort of a technology discontinuity in space, even if you're coming down with data that looks like it's meeting the same set of requirements, the downstream users, whether you're trying to construct a climate data record, whether you're putting that into a weather or climate model, many of those that depend on consistency, tightly defined consistency, the only way to achieve that will be to make adjustments, and you'll be constantly tuning the models, tuning the climate data records, tuning what other applications are to be able to deal with that technology change. So you can't always take the lowest best bidder every 5 years and expect that the costs for that downstream application are going to remain the same. There's that tuning cost, and there's a loss of continuity loss in the sense of consistency of the data, that those interruptions and disruptions. So I've used a lot of words to describe those first points, but that's really what it is. Pre-launch instrument test data must be contractually guaranteed, I think, to the community or to the government here. We've seen this as NOAA tried to put together its initial climate data records program starting around year 2007. We had PIs going back and trying to really draw more accuracy out of the weather instruments than they were originally designed to do. And to do that, you had to go back and say, what was happening in the test chambers, thermovac and so on. Can we see that test data? In some cases it was available, in some cases it was not. So if we start to think about how to use commercial data, all of that pre-launch test data, we want to make sure it is, number one, collected. There's a cost to it, certainly, but also preserved and becomes available to people who are trying to really tease out better performance in even post-mission use of the data than maybe was originally expected to be used for. I got a little bit concerned about on-orbit configuration. What if a higher payer comes along? Is this a data buy, or is this sort of NOAA investing in NOAA or NASA, some federal agency investing in a satellite? If it's a data buy, there has to be certain consistencies going along with that. There can't be a higher bidder or a U.S. military or some other buyer who comes along and says, well, actually, we need that satellite to be doing something else. That would not be acceptable, obviously, for climate and consistency and so on. Jumping down there to the bottom, I think sometimes, as I talk to the different modeling groups, and recently, particularly with the greenhouse gas modeling and carbon modeling groups, some of the hardest things they have to deal with are advances in technology. And that's a little bit of a head scratcher at first. Like, my goodness, we're giving you much better resolution or much better signal noise, but it's that, again, that disruption, the inconsistency, and in many cases, stability of the configuration or the technology, even if it's poor quality, poor performance than what could be achieved as the state-of-the-art stuff, that's actually desirable for some of the climate continuity, climate monitoring applications. Does that mean you don't jump to the new technologies? Not necessarily, but it's not a one or the other. So the point here is that you want sort of parallel tracks. Some things are doing the best stuff, particularly for process studies, that kind of thing, but that consistency, continuity of even a so-called dumber technology can be very useful to some groups. I think that's it, Betsy. Thanks so much.
Yeah, thanks. Thanks, Jeff. Next slide. Jeff and I think both want to encourage folks to fill in the gaps if we've missed positives or negatives here. Let's identify them. I want to just put this symposium here, this mini symposium, in context of what's going on in a broader perspective, and that there are currently activities going on in this direction in terms of public-private partnerships with NASA. Some people might have seen this announcement of 279 million going to 6 private platforms. Dwayne, Daniel, and I spoke with Kevin Murphy and Elfreda Hall from NASA's private satellite effort, and they shared quite a few of their thoughts with us in terms of related to the issue that we've already discussed about whether or not what we're talking about is augmentation or whether it's going to be the absolute fundamental part of our observing system. They pointed out the value of the ingenuity in the private sector collectively and individually, but they also expressed what Jeff was talking about in terms of viability and that sort of ability for us to count on these particular partners going forward. I think that's one of the things we're learning about in time as we go forward. But there's certainly interest in the added value that we can get from these. NASA indicated their desire to not be the primary source of funding for many of these efforts, but to tack on and pull off information that's valuable when the activity is already being funded, but certainly sees potential for growth in the coming years. Next slide. There's ongoing efforts within NOAA. I think NOAA has often led the way in terms of public-private partnerships, and the public-private relationships have been extremely successful in the weather enterprise. Okay, we might want to acknowledge that some of that got off to a rocky start, but there's now clarity of roles of what the private sector does and what the public sector does, but even those roles and the relationship is evolving. Some of that got codified into National Academy studies. Some of that just gets codified by the relationships being built. But I think that many of the benefits and challenges that we've discussed already, NOAA has already addressed them and really addressed them successfully when it comes to the weather enterprise. So I think it makes great sense for us to take lessons learned there and understand that there is the potential for great success. Next slide, please. And there are also a lot of activities going on within WMO. I'm here in Geneva now, and I had meetings today with WMO. Tatsuya Kimura, who's head of the private sector engagement, as well as Mingmi Li, met with Roberta Bascalo and myself, talking about how they could see private sector issues going forward. And they absolutely believe in the growth of this sector, the growth of the potential here, the possibilities moving forward. They have multiple declarations that are now including the private sector. And then we've also got WMO Resolution 1, which for those who aren't aware yet, it was passed last fall, and it really replaces WMO Resolution 40 and Resolution 60 with respect to weather and climate data. And the language for that agreement, that resolution, absolutely has the private sector identified as partners, and it is their hope that we can go forward for both weather and climate with private sector involvement. Next slide, please. So within the international context, we've got privately funded satellites that are rapidly growing, as our previous speaker so beautifully put forward. There are philanthropic organizations interested in getting involved in climate observations and are already involved. Their activities are growing in number, size, and complexity. Their benefits and challenges are apparent in all of these new activities. Next, please. So all I want to do is ask whether or not Jeff and I are missing anything in terms of the benefits and challenges, and whether anyone has thoughts on the roles for NGO observations. Who evaluates the observations? Who pays for them? What type of sharing agreements? When we're talking about climate observations, we're really talking about something that's of importance and benefit to the entire world. So how this goes forward is I feel, an open question. And with that, I really would love to see some raised hands. Daniel, are you going to moderate this?
Yeah,
Great.
and I'm not seeing any oh, we got first one. So we got one raised hand. Eric, you want to go ahead?
Yeah, thanks. You know, I have heard some technical things that, you know, that I wonder if they might belong in this conversation. One of them is, you know, when you use commercial satellites, you don't necessarily control the orbits, and you know, orbits that are exactly tied to the diurnal cycle, you know, equator crossing times fixed, are good. Orbits that are completely random are actually really good for radio occultation. The Cosmic 2 orbits are good for that. But if it's a commercial launch, then you may find that, you know, these are launches of opportunity and they have certain orbital configurations that are not optimal for observing things. You know, to make, for climate, the critical issue is to make sure that you don't get confused between the diurnal cycle and the long-term trends, you know, which is the equator crossing time drift issue. So that's something that I think would have to be looked at if you're really thinking about how you're going to use these observations. And I guess another issue that I've heard as a thing is, you know, if a satellite company sells data to NOAA or to another operational agency, they're going to try and sell, or they may choose to try and sell those soundings which are most beneficial to increasing the skill score of that particular operational system. And you know, if they're selling a smallish number of the total observations that they've taken, then quality control actually can create spurious trends in a climate record. You know, if there are peculiarities about that operational system that don't match the real world, if the operational system gets updated and then the selection criteria change, all those things I think you would probably want to know about if you're going to try and make a long-term record out of that data. So those are a couple of things. I think there are a few more that I've heard of, but I'm not sure. I'd have to dig for them a bit.
Yeah, I think that's a really great point, Eric. In particular, you know, so many of these challenges that I hear, I keep on wondering, well, can that be addressed in a properly written contract? Can that be addressed in properly written specifications? But when we talk about sort of piggybacking on someone else's purchased observations, whether it's the weather community, as you were just pointing out, could be preferentially asking for certain observations that are not in agreement with climate priorities, piggybacking on causes its own set of problems. So I'm wondering whether that's almost an argument for climate science criteria to be involved in observations that have the potential of being important to climate, as opposed to saying, oh yeah, you weather people, you pay for what you want, you buy what you want, we'll use it how we can. Is that what you're thinking, Eric?
Yeah, I mean, I guess there's a couple of things. You know, one of them is, you know, I don't really think we've had a conversation about level 0. And that may be because everybody at JPL kind of knows that, yeah, of course you need the level 0. But it may not be entirely clear what you mean by level 0. And being clear about that, you know, the RO, I think, experience is that you want multiple processing centers in multiple parts of the world, you know, the ROMSAF in Europe and UCAR and JPL, because when you look at the way they do their processing chains, you get really important information about structural uncertainties. And that matters very much. You could see this in the most recent IPCC report. You know, and, you know, well, let me just stop there. I guess you know, the other thing is that, you know, when we talk about, you know, requirements, it's sort of, you know, there could be various requirements, but it seems to me as though what matters is the requirements that are used in the contract, in the contract negotiations that the government is conducting. You know, so, you know, we would need to sort of specify that this data is not just being purchased as an input to weather forecasting. You know, and I don't know to what extent that's a NASA thing versus a NOAA thing.
Yeah, that's a great point. Can I just ask you your thoughts, because you're really bringing up stuff that highlights the who evaluates aspect. Are you concerned about that, or do you feel like, no, we can specify and that's a minor detail that can be addressed later?
Well, I mean, I guess in terms of who evaluates, it does seem to me that you need kind of objective players. I mean, I think being able to share the data, I think, is the most critical issue there. You know, that if NASA has data that is not able to share with international partners, then that's a problem, because, you know, up to now, I think we have relied on the fact that EUMETSAT has its own, you know, sort of processing shop for this data. And I think that that issue of needing a third party is important. I also think that some of these technical issues could be addressed, you know, for example, you know, with enough money and an academy study and sort of, you know, people really looking at the data. You know, whether this is good enough for level 0, I think, is a technical question that could be addressed by people who do this sort of thing for a living.
Thanks.
Betsy, this is Dallas
Yeah.
Nestos. Can I? Yeah.
Well, let's see. I think we had Dwayne, then Charlie, then Dallas. Is that okay?
Okay.
We go in that order.
Yeah, sure. I just wanted
order,
to join
order
that
of raised
conversation
hands.
because it was very sure.
Yeah, Daniel, I'll yield to Charlie and Dallas first. Go ahead. If there's time afterwards, I'll ask a question.
Okay. Go ahead, Charlie.
Yeah, I just wanted to jump in on sort of the last point there of who evaluates. And I wanted to note that right now with NOAA's commercial data buys of RO data, we actually have a third party evaluated. It's UCAR. And I think this is a great opportunity for the academic sector to sort of play an objective, honest broker on the value of certain data. The other thing I would note is that, you know, one of the frustrations I would have as a buyer of data from the government is sort of the reluctance of certain commercial providers to have free, open, available archives for the academic sector to prove and validate. You know, and so, you know, if they're going to sell wares that are better, cheaper, faster, more useful, I would like to have the peer-reviewed best available science show me that it's actually all of those things. And so, you know, the evaluation part for me is critical because I don't want to be, as a buyer, responsible for proving that data that I've already bought is useful.
Charlie, I couldn't agree with you more. I just think that that was perfectly said. We don't
Maybe
want just one set of eyes on it. We want a community on it.
Okay. It might be just a partial answer to that concern, at least relative to the NASA thing and what we learned and know from the NASA side. When they even think about purchasing data, they usually have some sort of call that involves people providing an evaluation and write-ups on that on behalf of NASA before they purchase. So they at least build that in to some extent. Others may want to add to that, but I just wanted to throw that in, Daniel, as a partial answer.
Yeah, no, I was going to make the same point. I think it's good to highlight, right? I think NASA has a similar approach to NOAA where it's two-step, you know, evaluations, then commit to buying more data and making the data available to the NASA science community. But let's go ahead. Thanks, Charlie.
I think Charlie was actually proposing something more ambitious. So really having multiple academic eyes on it, not a contract out to evaluate it, to really allow some peer-reviewed examination and multiple examinations. I thought Charlie was suggesting something a little different from the historic model.
And Betsy, that's correct. And that's sort of a personal bias that I'd like to clarify, which is I would personally like to see a lot more eyes on these data because it makes it a lot easier for me to make my make or buy decision.
And I think that a lot more eyes can end up finding the sort of bits of gold within what might be an otherwise messy situation.
No, great point. Okay, let's go ahead and hit Dallas.
Yeah, I just
If you guys can put your hand down, sorry, if you're done, please lower your hand so we don't get confused.
Yeah, I just wanted to speak to some of these comments. These are all excellent comments, and they touch on a lot of things. And I have experience in a lot of these questions, so I wanted to add some color here. If you approach a private company and you say you want a particular type of data to be produced, there could be very different perspectives if you want it for climate or you want it for weather. And I think you touched on it perfectly, Betsy. So if NOAA is interested to buy radio occultation data for operational weather forecasting, that's much different than if NOAA came or any entity came to that same company and asked for climate data. And you've hit on a lot of things where clarity of the requirements is really important. If all of the above is is what you really want from the company, then the entities that are wanting to buy the data NASA and NOAA should probably get together and formulate those requirements such that they can be met by the companies. But I think there's a lot of nuance to that as well. In the space of radio occultation, it's really important to have a lot of data. And it may not be that important for climate, but it is for the weather part to have a lot of data. And the private companies right now can produce a lot of data. And probably in the next couple of years, we'll see the impact of that. Another thing about the orbits and the selection of orbits, these are things that can be made into requirements. And I think that those requirements, like what orbits satellites got launched into for radio occultations, those were not actually requirements. And so the companies went out and cost effectively chose orbits that they could get satellites into. And some of those orbits are actually beneficial. So if you look at the RO orbits that come from commercial providers, you'll see that they are actually adding a lot of diversity. But if it's important for those types of things to be specified for safer climate, it just all it means is that we make those requirements on the companies to produce data in that fashion. And I don't think that the companies are any different than the government programs. I think that there's a lot of overlap in terms of what the companies have to produce and the same types of challenges that there was a slide here that talked about challenges to NGO data providers. A lot of those challenges are the same challenges that government programs have: continuity of data, changes to the systems. But I do think that the companies can bring a lot of benefits too, even though they have the same challenges. And the speed that companies can produce data, the flexibility that companies can have in terms of changing and providing something new is also a benefit. So I just want to make those comments.
Thank you. Thank you.
Okay, looks like we've got Ian as our last raised hand here. So Ian, go ahead.
Hi, yes, thank you. That was great, Betsy. I was going to echo what Dan and Dwayne were saying about the NASA program. I'm not as familiar with the NOAA commercial data program, but with the NASA data program, it's definitely looking at how particular vendors can provide data to NASA. I wonder and so that's a team that's evaluated through a ROSA solicitation and then works together for a year. I think it's a great program. How much is the responsibility of the NGO or the private company to work with academia? Getting back to, I think it was Eric's question or statement about, peer review. Should they be investing their own funds to get the data out there and evaluated for other applications outside of what NASA or NOAA is doing? And obviously with the smaller startup companies, that's difficult, but maybe their VCs, instead of going after more investments, would be willing to invest in those sorts of efforts. But also, as they're growing, I'll just choose a planet, a large scale one. Isn't it on their profit margins to kind of look at investing in evaluating, getting articles out there? As you look up these companies, there's not so much in the peer-reviewed literature, and it seems like it would fall somewhat on the investment of the company itself. So I just wanted to add that statement there, but thank you.
Thanks, Ian. And was it a statement, or were you hoping that Dallas or one of us would respond to it? Because I think your statement is a strong and solid one as it is.
I think my statement's solid, but I would be happy to hear Dallas's opinion on that, as he's in that, in the muon realm, and they're really moving forward, and he obviously has heritage there. So, Dallas, would you like to take that on? Also, okay, leaving it standing as is.
Sure, I can give a perspective on that. You're right. In the commercial world, you're always trying to move really quickly, and peer-reviewed articles, kind of like in an academic sense, is kind of a slower process. And there's pressure to keep moving forward and not take the time to write papers on your data sets. But I think that from the commercial sector has still the same goals to provide the information about the data that we're producing, engaging with academics as well to qualify those data sets. Muon Space for sure is very interested to work with academic partners that have expertise in certain fields, so that we are meeting the requirements of NASA, NOAA, and other entities. And if it's a requirement that we that we publish these results and get it out into the peer review, I think we can do that. I'm sorry, there's some background noise. And so I think the perspectives are the same. I don't think that the commercial world has a different perspective, but there definitely is a kind of faster pace of evolution in the commercial world, and not a lot of time to stop and publish results. And that's something we just have to work on and do better at.
Yeah, Dallas. I mean, I realize, the commercial world is a very different speed than, where we are in the government. But at the same time, as I do this market evaluation on the small satellite providers, there's a lot of emphasis on media, right, which is gaining the attention of investors. But at the same time, you're in a multi-market space, right, where if you're really trying to gain traction with the government agencies, that peer-reviewed academia realm is really what gives you credibility, right? I mean, I'm not saying that media is not giving you credibility. It's just a very small snapshot on a particular application, and it doesn't delve into the long-term usefulness of the data. It's more just a marketing technique. And I'm not throwing stones at that. I'm just acknowledging, media is very different than a publication.
I can just say that I worry more about what NASA and NOAA thinks about a data set that I produced than anything else. I mean, I think that I want the community to be happy with the data we produce, and I'm looking at those customers all the time.
Okay,
This has
thanks.
been wonderful. Yeah.
Yep.
I think this has been a wonderful exchange. Thank you.
Can I just make one more comment? Because this is just to add to this conversation, a couple of kind of technical issues. One is, one of the things I think we'll never see, one of the things I have not seen in licenses, because NOAA has a whole suite of licenses and NASA does too, is redistribution rights. Because allowing someone else to host and serve your data, the raw data, is a really big deal. And yet, that's how the world works on the public side. I mean, ROMSAF does, in fact, host and serve data from the cosmic missions, and the UCAR Center does the same for the EUMETSAT missions. And that's tremendously advantageous when you want people who are in academia, who are in this sort of evaluation role, to be able to look at this data, so they can have it all curated by the same people, have all the file formats the same, and so on and so forth. So that's one thing. It's a technical issue, but I think it's going to matter considerably if you want people to really look at the data. And it's a really big deal, I think, if you're writing a license and paying for it. Another point that I kind of wanted to bring up is, the experience, as I understand it, at UCAR, is that they will take a satellite of opportunity, and I'm thinking of the one from Korea, which I think is COMSAT 5, and do the plumbing so that data from that satellite can be used operationally and archived for research. And from what I understood, it took them about 6 months to figure out the instrument characteristics. And that's fine, because COMSAT 5 is probably going to be on orbit for 5 or 6 years. But if it's going to take you 6 months to do every one of the CubeSats, which are only on orbit for a couple of years each or something like that, and the instruments are being continually improved, then I don't know to what extent it really is practical. I don't know how much of that data you're really ever going to be able to process and homogenize the way you would want to for climate records. And it may be that it doesn't have to take 6 months. There are ways of accelerating that process and so on and so forth. But as of now, it's not clear to me that it's really practical to use data for climate if it takes that long to sort out the characteristics of the data and it goes away after a couple of years. I think the UCAR Data Center, when it was doing that, was running somewhere between $3 or $4 million a year, and only looking at a handful of these satellites. So, you really need to kind of figure out what it would cost to do that on a large scale.
I agree, Eric, and the redistribution issue is one that has come up with other data sets. For instance, when Panasonic was selling its aviation data to NOAA, or trying to do that, and didn't want it redistributed, and that was against a lot of the WMO and international agreements. And I believe that the current Resolution 1 is going to imply a similar restriction. So all of that, it would affect the price. all of that would completely adjust the private sector's costs. So it's not just a matter of writing the contract appropriately. You have to be able to be willing to pay for what you want. And if what you want is redistribution, then that's more.
Okay, thanks, Betsy. So just a little time check. We will have about an hour and a half left. I was just going to comment in the chat. Felix also put a comment in there saying NASA classically has mission-specific science teams with the task to V&V data, and it seems like a new paradigm would be needed for NGO data contributions. I think that ties exactly into the conversation that you guys were just having, right? And it's maybe another model. Let's see, I think at this point, I don't see any more raised hands, and because we do want to make sure we have time for everything at the end, I'm going to propose we go ahead and move forward with section 4. So Jeff, we can go to your slides.
Okay, thanks very much.
Thanks, Betsy. And Jeff, good conversation.
Yeah, and that was a great discussion. I really actually enjoyed that. I was busy taking notes during that. Okay, I'm not seeing the presentation up.
I think you wanted Wingsay to do it, right? Yeah.
Yes, correct.
Thank you, Wingsay.
There it is. Okay, thank you. Okay, first I want to call out both Betsy and Chris Ruff for contributing thoughts and slides and reviewing and helping me with this presentation. And there are a few slides that Chris directly created. So when I get to that point, Chris, I'll just hand off the microphone to you. And if you can walk through those, then I'll come back and do the sort of wrap up. Okay, so this is our attempt to take a look at what really can we do in the either ECV space or the WCRP challenges space with the either existing capabilities or what we believe to be maturing capabilities of the NGO space assets. Okay, next slide, please. So a quick outline. First, I want to go over the World Climate Research Program's grand challenges. That was to be part of this. I was less familiar with those. I come from more of the GCOS state variable sort of space. And when I looked at these first, well, I'll get to it in a second, but I think there's really some fertile ground here that we can look at. I'm going to talk a little bit about the NOAA's commercial weather data pilot because I think there's some lessons learned. Yes, it's weather, not climate, but I think the approach to doing it and some of the discussion that was just had is relevant here. So I'll go over a couple points there. Then Chris is going to talk about new space, the pull and the push opportunities for engagement with the different NGOs. And also he's going to talk about hybrid space architecture and a few of these different things, including that one. In fact, Alice has sort of made a little bit of a reference to it. Is, what about the combination of public and private, different assets in space, but kind of working together? I think there's some very interesting ideas there. And finally, what really can we do to leverage the commercial space for the actual problems that we're talking about here? Okay, next slide, please. So what are the weather, the World Climate Research Program's grand challenges? There is 7 or 8 little sort of tenets of this, and I'll go through these very quickly. First, they are specific barriers to preventing progress in critical areas. So they're very critical, important sort of places where we have gaps and we need to get across those gaps. They are places where the community believes that there's likelihood of significant progress over 5 or 10 years. So there might be some new technology coming on board. So for instance, new space or something like that, that they believe would actually allow us to bridge that gap. They could have effective and measurable performance metrics. So we know how we're doing. They would be transformative. They would really fundamentally, get us across the bridge and be able to potentially accelerate in some understanding of the climate system. They would capture the public's imagination, which is always good for PR and sort of getting sort of a groundswell of not only support, but actually participation by the different parts of science, and offer compelling storylines. Again, you've got to get, when you're talking about something like this across the world, you've got to get interest and support behind you. These are not simple problems, and they need investment both in time and money and energy. And so we can understand why those are there. So these are our big chips that we're talking about here. Next slide, please. And they've gone ahead and identified these. So I've pulled these right off the website. Like I said, I was not too familiar with these before I got into this, but I think there's really some interesting things here. I'm not going to go talk about the sub bullets because those are sort of additional questions and nuances around the original bullets. So let's just sort of talk at the top bullets. Melting ice and global consequences of that, cloud circulation and climate sensitivity to clouds and circulation, carbon feedbacks in the climate system, weather and climate extremes. We've already seen extremes come up several times. Water for the food baskets of the world, regional sea level change and coastal impacts, which we see all over the place in NOAA, and near-term climate prediction. So what are there? About 7 there. And some of these are, a lot of these are a little bit more process related than they are sort of long-term monitoring, even if you could achieve part of the progress through long-term monitoring programs. Okay, more to that later. Next slide, please. So now a little bit about NOAA's Commercial Weather Data Pilot, CWDP. And a couple things to note here. I'm going to go through different rounds. And I think one, different sort of RFIs that have gone, requests for information or requests for proposals or source selection information, sources sought notices. There are different tools that the federal government is using here depending on its understanding of what's out there and its ability and desire to go out and commit to something. And I think this is instructive in that you sort of start with asking the big question and you get the commercial sector to provide some information that helps guide what's going to become an RFP, where you're ultimately trying to say, this is exactly what I need. And that leads to a contract and so on and so forth. So it's not a step function from, we didn't have it, we have some requirements, let's do a call and get some company to be able to provide those requirements. It's a very methodical process to first understand the landscape. How's the landscape evolving? Is it even appropriate to be talking about a non-federal sensor going to the private sector, or is that not something that's a good idea? Okay, so for NOAA, they did a round 1 looking for GNSS-RO data, and the first conclusion was it's not there yet. There's some research capability, but it's not going to be sufficient to meet operational need. So come back in a few years. Round 2 concluded that now the RO data is adequate. It can be used operationally, and NOAA in this case offered 2 IDIQ contracts for the, I should say GNSS-RO, rather than GPS-RO. And even then, there was different data buys, structured data buys to first get it in, start to evaluate these data with the weather models. Once there was some proof that it would bring value, there was a cost value ratio that was positive, then going out and buying more data. And you'll see in a further slide, we started with fewer and then we build up to more and more. Round 3 was an interesting thing, which is to say, can we do microwave sounding, do atmospheric profiling using traditional microwave sensors? Round 4, space weather. Can we do, again, profiling of the atmosphere, the ionosphere, and so on to get space weather information? And in fact, on this one, if you were watching the news just yesterday, NOAA has let out 3 awards to 3 different contracts, 2 different companies to be providing the initial tranche of space weather data. We do have plans then for a more general RFI and say across all of the NESDIS level requirements, where is industry? Which of the NESDIS requirements can be met by the federal sector? And obviously based on that RFI, then we'll start to put together RFPs as appropriate. So going forward, then we expect to be doing this sort of structurally, programmatically, routinely going out and again, collecting information and then figuring out what to do. And if we do want to move forward, doing the RFP and then the evaluations of the data. Next slide, please. Okay, and this just shows these, we call them delivery orders. You see on the far left side, 1 through 5, there, the vendors in the next column over, showing, you know, back and forth, how many profiles. This is a GNSS RO data, remember, you know, starting with small numbers, doing some short-term periods, doing tests, evaluations. Can it be used operationally? Even if it can be used in a research sense, high accuracy, can it actually make that step into operations? Not always easy. Then you see, as we're coming down the rows, the number of profiles and the time periods that we're talking about increased as the government began seeing the value, exploiting the value, and growing, getting confidence in this. Next slide, please. And this just shows it graphically. You know, time is on the x-axis going left to right. The number of profiles is on the y-axis. The different companies represent, or I'm sorry, the different colors represent the two companies in this initial GNSS-RO acquisition, GeoOptics and Spire in this case. The dashed line there represents the number of profiles that were part of the contract, that was written into the contract. The light colored dots, the smaller dots, represent the total number that was potentially available, and the darker solid marks represent what was actually compliant with the contract. So one thing you see is the growth. One thing you see as, you know, in working with the commercial sector, typically they were overproducing. Not everything was going to be compliant, but they were, you know, particularly in the middle there, you see there was a overperformance, if you will. They were delivering more than the contract required. And you also see the number of points which are non-compliant, particularly in the red, the Spire contract. By the time you get to the far right, we're getting a lot more data. Almost all of it is compliant. Just, I don't even know how many, but basically 99% are compliant. So private sector learning how to work with the public sector learning how to work with the private sector. But in just a few years, tremendous growth. You know, there's a learning curve on both sides, and I think it's a very positive sign. Next slide, please. We talked to, somebody mentioned a little bit before, data distribution. You can, I reduce this a little bit, but you see different parts of NOAA, NWS, and NESDIS, military, Navy, Air Force, Goddard, NRL. So a variety of US government users, some international partners, particularly these partners are either through WMO, the partnership and the WMO members, or CGMS members. And there are certain requirements that go along with being parts of those organizations that require you to share data. And in this particular case, the research community, the open use of it, there's a delayed reception of it of 24 hours, but then it's opened up to everybody. There are different models. Next slide, please. And here are some of the different models, at least in the structure that NOAA uses. The best, you know, the best is towards the top, the more restrictive toward the bottom. So option one, unlimited. Anybody can get it very quickly. Option number two, a subset starting with the US government, key partners and so on, get it next. Academic, you see at the very end, academic entities for non-commercial use with no further distribution. Option 2A, that plus unlimited distribution after 24 hours, and so on. I'm not going to go through all these, but this would be part of the contract, right? Looking at these different things, understanding, in our case, NOAA's requirements with the organizations that it works with to make data available, and trying to sort of work in that trade space. Next slide, please. And so Daniel and others out of JPL got a list of the GCOS essential climate variables and the products for the different ECVs and some of the different requirements that went along with them. And we did a couple things. Number one is we looked at the existing US government or international agency assets that could be measuring these different variables, and then created a number of columns further to the right, which said, what about the NGO space, private, academic, philanthropical efforts and things like that? Is there something planned? Is there something that's already up there? Or can we reasonably expect something to be coming online soon? Is the technology evolving? And if so, at what level is the technology? So it's not done. It's a lot of work. It requires people from a lot of different fields to help fill this out, but we got to start on it. And I think that's the important thing. So if you look through some of this things, the GCOS ECV list, by the way, this is a 2016, there's a new list, which is largely the same, but it's got some additional stuff, which is currently in review by GCOS. That's going to be coming out either later this year, possibly next year. So we're working a little bit with old information, but I think it's instructive anyway. Third bullet there, 74 of the derived products probably can be measured from space. So that's perhaps sort of the space that we're working in there. Potentially 74 different products we could achieve with or without NGO contributions. You see then in the next thing, commercial opportunities, a partial review or partial filling in of the spreadsheet indicates roughly 5 of the 74 measurements are likely amenable to new space or NGO observation in the next 10 to 15 years. We know about atmospheric sounding by GNSSRO. I'm having the hardest time with that today. As I just talked about, we know there's some advances and there's been very known usefulness in land cover, ice velocity, and feature tracking. 8 of the 74 may be amenable to NGO observation, and 5 of the 74 just likely, we can say, are not likely. It's not going to happen. But importantly, at the bottom, 56 of the ECVs, we really haven't done a deep dive, or we haven't brought the right experts in to be able to guide us yet. So I think this is it's the first such sheet that I've seen. I think it's an important thing, and maybe sort of this is the starting point of bringing in the wider community to help us get this thing filled out. And I think there'll be an effort then to keep it current over time going forward. And by the way, and I think this is going to be very helpful to future decadal survey teams if we do keep this thing going. Next slide. Okay, here's where I'm going to hand off to Chris.
All right, thanks, Jeff. So yeah, the next few slides address a few things related to engagement with new space. And this first one is just 2 different ways to think about how to go about engaging with them. And I think they're probably both, I'm sure they're both relevant depending on the situation. The first one is, I would argue, the more traditional one, the one that you sort of think of first, which is pull engagement, where you go out and see what's out there, who's developing sensors and what their capabilities are and what their orbits are and so on, and or what their data properties are. And if they meet your needs, your ECV needs, then you buy them or check them out and see if you might want to work with them. And when you do that, there's, you know, a handful of things that you do to make sure they're going to get the job done. If, you know, you look at what they're actually measuring to see if they're the right things that you need for your essential climate variable work. And if they are, then you evaluate them to see if they're good enough. Resolution, coverage, sampling, and especially the you know, the calibration, stability, and noise properties, and you know, whether they're good enough and that they built it right and calibrated it right. And then the third main area I would argue is whether they're reliable, and reliable in terms of are they going to be there for the long haul? Are they going to maintain the quality that you want? And if and when they change, which they will over time if they don't stay in one place and they're improving their technology and so on, if they're transparent about the changes, I think that's an important element also, so that if they improve, you need to know that they improve or how they improved. I think Jeff earlier mentioned that maybe sometimes it's better to have stable data than better data. And this would be an example of the information you'd need to make that trade analysis. So those are sort of pull engagement kind of rules of the road. And an alternative way of doing this, going about this, is a push engagement, where you help you, the government, the customer, work with the data providers to see if they can do the thing or help them do the things that you want done in the ways that you want done. And I think you could break this problem up, the push issue, into 3 different general areas of, satellite constellation data providing. One of them is the sensors that are on the instrument. Another is the platforms themselves. And the third is getting the data from the satellite into the user's hands. And in each one of those cases, for example, for the satellite or for the sensors, there's this huge explosion of new small sat class, CubeSat class, smaller satellites, smaller sensors, lower power, et cetera, that have excellent capability. And just identifying what those sensors are. They may not be sensors a particular company that flies satellites is working with, but you could couple them together if they knew there was a business case to be made for doing that. So identifying sensors. Another is identifying the platforms and platform providers and seeing if they've got platforms that are adequate to accommodate those sensors that you've identified, and put them together into a viable mission that meets your needs. And then the last one is, data providers, ground stations, making sure they've got the bandwidth and the capability. And in the latter 2 cases, especially making sure that these providers are going to be around for the long haul to meet your long-term data needs. So so you can engage with them before they've started making their products and work with them to basically have, bespoke NGO missions that meet ECV needs. That's the idea. And I think, both of these approaches have a place in the sort of the new ecosystem that's coming, in the next, it's sort of here now, but it's going to keep growing in the next 10 years. All right, next slide. Right, so hybrid space architecture is a phrase that comes up a lot in the that recent National Academies report, which my last slide is a quick summary of that report. But the general idea is to try to combine together the traditional space things that have been done in the past, mostly, space agency led large missions to do Earth science measurements, and combining those together with the things that the small sat companies and the NGOs are arguably better at doing. And as an example of this, I just picked one of those lines in the GCOS ECV matrix that Jeff was just talking about. This is one out of the 80-some different environmental data record, measurements, upper tropospheric water vapor. And it has these requirements that are needed to meet the needs of long-term climate trending and analysis. So 2 of these in particular, I think the revisit time, hourly revisit time, and the long-term stability of the data product are, in my mind, they're drivers for the design of a mission that does this. And the long-term stability, 0.3%, is a really small number and not easy to do. And I would argue that sort of requirement is just lends itself a lot more naturally to the traditional space approach, where you've got specifically designed instruments and platforms that are designed for this particular mission, with complete control by the government and how they're being calibrated and how they're being characterized before launch. And then once they're up there, there's a support system of a VMV team and all the sort of normal things that happen with with an expensive high quality for science mission. Those are the sorts of things that you would think you're going to need to meet a really tight long-term training requirement. Another requirement is the hourly visit time. That one really lends itself well to new space, where you can afford to throw up dozens of satellites for the same cost as one big expensive one, kind of thing. And that's a good way to get to hourly revisits. So the question is how to couple these 2 things that are the strengths of these 2 different approaches, traditional and new space. And the hybrid space architecture, just in general, is about trying to couple these 2 things together and have them complement each other, not compete, but complement. And so a way to do that in this particular case would be to take the traditional space platform or platforms that have fantastic long-term stability, use them as a gold standard against which you would do inter-satellite calibration with the constellation of small sats that give you the hourly revisit. And then you can bootstrap the long-term stability of the big expensive one onto the, the large and cheap ones. It's an example of a hybrid space architecture that can meet the needs of this, this ECV, water vapor, environmental data record. And the next slide is an example of exactly this kind of calibration bootstrapping, which was done in great detail over a number of years by the NASA PMM mission. And it's the NASA GPM XCal group, which I was on for quite a while when it was first getting off the ground. And if we go to the next slide, it kind of summarizes what's going on here. So the idea with NASA's GPM XCal was, one of the main goals of the GPM mission or the PMM mission was to sample the global precip a lot more often than TRMM did, which was the precursor mission, in order to capture some of these short time scale events like convective rain that gets missed all the time by a single satellite. And so the only reasonable way to do that is with a big constellation, and there was nowhere near enough funding for this mission to fly a whole bunch of these satellites. So what was done instead was to fly one sort of gold standard satellite, which is the GPM Core Observatory, and then to just round up basically every satellite out there that wasn't necessarily part of GPM. I mean, none of them were. Every satellite that had a sensor on it that could plausibly do a reasonable job of estimating precip. And that included a lot of different microwave sounders and imagers, which are sensitive to the precip, but they weren't designed as precip missions. They were calibrated for other things, or they weren't calibrated as stably as GPM needed, and so on. So that was the sort of the going in process. Those are the tools for all these different satellites. And then what XCal did was figured out how to do sufficiently high quality inter-satellite calibration between sensors, which are not the same at all. They are very different from each other. Some were similar, some were quite different, but to figure out how to intercalibrate them so that you could get a consistent long-term trended precip data product where the precip coming out of every one of these was consistent with the precip from every other one, even though the sensors were different and were not as stable. And the XCal process went on for a long time. And I would say just in general, and I think there's a lot to be learned from this that could be leveraged for this new engagement with NGOs. And I just copied here a note that Felix made in the chat earlier saying, NASA classically has mission-specific V&V teams, and it seems like a new paradigm would be needed for NGO data contributions. And I think this is exactly an example of that type of paradigm. If you had something like XCal to support each ECV, leveraging all these new small sats that are coming online that are all different from each other and may not be exactly what you need, but fill in all kinds of temporal sampling gaps. And you had something like the GPM microwave imager, which was the gold standard that was used to help tie them all together. So just, quickly, the way that XCal worked, just the process we went through, I would say more or less in like the first 3 years of the XCal process, we spent a lot of time modeling and thinking about what does it mean to be consistent. You need all these different satellites that aren't the same as each other. They don't measure the same parts of the spectrum, and they don't measure the same incidence angles, all these differences. What does it mean to be consistent? And one of the things we arrived at, or conclusions we arrived at early, is to be consistent means that the level 1 data products, the radiances, are consistent with each other, not the level 2 precip products. And that was so that you had some faith over the long term that, the ways that you derive precip from radiance can change over time because it's dependent on the nature of the rain. And, there's different algorithms if it's stratiform or convective and that sort of thing. And you don't want your algorithms to be tied to those sort of assumptions. So we wanted to go back to the radiances, but how do you make radiances consistent when they're not measuring the same parts of the spectrum? And so we use this sort of radiative transfer based double differencing thing that we spent years getting it right, so that we had some faith in the consistency of the intercalibration between satellites that weren't the same as each other. And then the next question was, how do you measure the consistency? And so we have all these residuals that are a measure of how well individual satellites fit, match up with these double difference radiative transfer analyses. And then the next step was, how much confidence do you have in your assessment of the consistency? And for that, we had a handful of different approaches to the consistency test and the residual analysis that were independent and different, statistical properties of the radiances that needed to be consistent, basically, but different ones that were affected by different types of calibration problems. And then we looked at how well these different approaches agreed with each other. And if they didn't agree with each other, if one approach thought that a particular satellite was consistently intercalibrated and another one thought it wasn't as much, then we had less confidence in that particular satellite. And you can see in this picture here all these different satellites, and I'm not going to name names, but I'll just say some of them were a lot more stable than others. Some of them were given a lot are today given a lot less weight than others in the globally assimilated precipitation data product because of their the lack of confidence in their intercalibration consistency, their forced interconsistency when we retune the calibration of the radiances. And then finally, how do you just sort of, there's this underlying need to have a gold standard to do this, and we use the microwave imager on GPM itself as the gold standard, and there was a number of reasons for that. One of them is we thought it was probably going to have excellent long-term stability. That was just a guess because we didn't know going in until it got up there, and it's been up there for a while, and it is. But it was designed, the calibration system was designed to be really stable, but also because it was it was contracted, this instrument contracted for this mission. There was complete control over exactly what it was, how it was designed, how it was tested, the sharing of all the pre-launch test data, all that stuff was available to the XCal team, and that was very valuable. So that's an example of how to do intercalibration or hybrid architecture calibration between a rock solid traditional instrument and a bunch of others that are A, you don't know as much about, B, they may not be exactly what you wanted, and C, they're not all the same as each other. So you need some way to do intercalibration. So I think there's a lot of, I think there's a lot of lessons learned to be gleaned from this XCal process as we look into the future for new missions that engage both new space and traditional space. Okay, I think there's one last slide here. And yeah, this is just a real quick summary of this National Academy's report that came out a couple months ago, and it's online if you want to read it. And these are just a couple of the key takeaways from the report that I thought were especially relevant to what we're talking about today. First of all, just in general, the statement of tasks that we got, this was a request from ONR to the National Academies to do this report. But it was to look at potential, how to exploit public-private partnerships, the government agencies working with these NGOs, basically, to develop, deploy, and operate, flight systems to support ocean and atmosphere needs of the Navy in particular for this contract, but it's really much more general than that. And the general observations that come out of the report is that, there's what we've already been saying today. There's this huge explosion of new space technology that's going up, and the small sats that are flying with the instruments that are on them have a huge potential to affect to support the needs of the government agencies. And then conclusions and recommendations. One was that the U.S. government should embrace this with public-private partnerships involving. Actually, there's one important point here. This idea of anchor tenancies is something that was brought up by. Well, let me back up a minute and say this: the panel that wrote this report, which I was on, Pat was on, There were only a few of us that were really like earth science people. A bunch of the people on it had a lot of experience working in major procurement offices on the DoD side for space asset procurement, and just what is involved in, you know, the government buying big things from big companies, and the impediments and the way the system works to working with smaller companies. And so a lot of the recommendations are kind of like useful, kind of bureaucratic kinds of things about how to get this sort of stuff to actually happen, and just the way the government lets large contracts. And one of the things that was brought up a number of times by these people, and it shows up in the report, is this idea of anchor tenancies, where you know, it's the idea, it's borrowed, you know, the phrase I think is borrowed from like the really big box stores and malls, right, that keep a mall running. So you've got whatever, Macy's or Sears or something there. And you know, if you've got a small company and it has an anchor customer like the US government, it's not their only customer, but it's a customer that they can rely on for, you know, contracts and business over decades. It gives them a lot more sort of, I don't know, peace of mind and latitude to get investors and to hire and to make, you know, business decisions that are not just worrying about the next quarter. And it stabilizes in a lot of ways. It can stabilize the business. And so that's the upside for the company. The upside for the government, if they're an anchor tenant for one of these small companies, is that it gives them more of you know, a say in what the company does. And for example, things like what level of testing they're going to do before they fly, and how much they're going to share that testing, you know, the pre-launch hardware characterization testing that you need to really understand how to do level 1 calibration with high quality, those sorts of things. And then finally, this idea of involving academic institutions in this work. I think this gets back to something that Charlie mentioned earlier. You know, having multiple groups independently assessing the quality of data. It was something that was really useful for the GPM-XCal experience, where we had multiple ways of assessing the consistency of calibration between satellites. And we required that independent ways of doing this were consistently saying that the thing was consistently calibrated before we had confidence in that particular instrument. And you could do the same sort of thing here. You could have independent groups, whether it's government labs or academic institutions, doing quality assessments, and you want to have independent looks at it, say that it's okay before you have confidence that it is. And then finally, the hybrid space architecture is just, you know, the general idea of not trying to replace one with the other, you know, new space and traditional space, but to try to, you know, pick out the fundamental strengths, or the major strengths of each of these two, and use those strengths and keep them around, and then figure out some way to combine the two together in some way that that they can both, you know, benefit from the other strengths. You know, new space is probably having a lot more satellites up there for better revisit times, and traditional space having rock solid hardware and a support team on the ground that keeps the calibration stable over decades, that sort of thing. And yeah, that's it. That's my last slide.
Okay, thanks so much, Chris. I appreciate that. Okay, so now I'm just going to sort of go through various discussion and or debate points. Some are just sort of summaries, and some are intended to be more or less provocative, depending on the thing. So partly to sort of stretch our thinking a little bit, and to generate some questions back or some comments on these. So again, what do we mean by an NGO or a new space opportunity? And Chris talked about this. There can be a push, there can be a pull, there can be both. What is an appropriate government role? Is it to incentivize it? Maybe, you know, industry tax breaks, do some upfront investment, impart requirements, pre-launch testing requirements, again, as Chris has talked about, to acquire and be the distribution point, open up the data to everybody at no cost, or simply to leverage it for climate purposes. There are lots of different roles that could be played there. If government doesn't do this, might it still get done? So for instance, insurance and reinsurance is huge sectors. They have interests in seeing this field, this space prosper and grow and evolve, and finance, energy, the same thing. So they may come online and be willing to do this even if government doesn't. And that's an interesting trade to think about. So data buys, is that what we're talking about here? But that can be a little bit more passive. I think we all agreed that that was, just there'd have to be a lot more than a traditional data buy to ensure that we fully understand the sensor, that the tests, the measurements on the performance were made prior to launch. So that would be a very intensive data buy. And so then the last of that sort of just keeps sort of getting on that same theme. So let's move to the next one. If we look at the spreadsheet, I think we can start to draw some early conclusions. Again, it's not a comprehensive evaluation yet, it will be, but some things did pop out already. So some current NGO core strengths, acknowledging that, why do private sector businesses build and launch technologies? It's to make money, right? So not everything up there in the new space is profit making, but much of it is. And so what does that lead companies to make? Well, there are very high spatial resolution, much higher than we have from federal assets, and high frequency has been talked about earlier. Most of not all of it's multispectral, but much of it is. So high spatial, high frequency pictures. This, if you've been following the Ukraine conflict, there's been picture after picture after picture showing amazing detail of the battlefield, tanks and so on. That's something that you're not going to do even with Landsat. And there are companies right and left that are able to provide these amazing pictures. The GPSRO, we know that works, right? We have evidence now in the NOAA case. But why does that work? It's more of a solid state technology. It's relatively cheap. You can sort of mass produce it. I know there's more to it than that, but compared to an optical sensor, there are economies of scale of sort of rebuilding the same brick, and you are going to have to order a lot of those. So there's going to be very large orders, and then you can put together the very large constellation that's needed for enough occultations. Another sort of place where there's some core strengths in the NGO field is, I would say, the frontiers of innovation, things coming out of universities or startup companies where some brilliant ideas are going to be tested. And there's not currently a plan for follow-on necessarily, but can we build it? Will it work in space? You do a demonstrator, and then you sort of see what comes out. And that's something that works very well, I think, in this space. Finally, for lack of a better word, I don't know what to call these things, advocacy sats or passion sats. And this one I've only known about for a couple of years now, but Environmental Defense Fund's methane sat, which is going to fill an interesting niche between sort of like Schimaki, Chaponi level sensors, and then the very high spatial resolution greenhouse gas sensors, which are looking at things like point sources, individual facilities. And the Environmental Defense Fund is putting up something that's sort of at the field scale level measurement, not quite point, but a little bit broader than that, but not as broad as Chaponi or something. And then they're going to make this data openly available. There's not going to be a charge to get at that data. Will it be good? How good is it? Is it qualitative or is it quantitative? The proof will be in the pudding, but it's something that's new. And I think it was Betsy who said there seems to be a lot more interest in people who have the money, or organizations that have the money, doing more of this sorts of things. So this is an very interesting development. Next big point. Again, looking at the spreadsheet, doing this sort of first level analysis, it appears that are not so many global scale ECVs, which are usually state variables in most cases. They're not, again, this is different than the WCRP challenges, which are a little bit about processes and fundamental science and understanding. ECV is a little bit about long-term monitoring purposes, but relatively few are adequately measured by the current NGO space. Doesn't mean that won't change, but that was sort of an early read. And I'm sure there's people who are going to add caveats and corrections to what I'm saying right now, but that's part of the point of this presentation. The one great exception, obviously, is in the GNSS-RO space, where we know that doing the atmospheric profiling and now space weather profiling not only can be done, but is being done and is bringing value to the federal government. But given that, and particularly if we go back to things like what I said two bullets ago in the high spatial resolution, high frequency places, that doesn't mean, even if they're not doing ECVs or things, I think Betsy called these not just changes, but changes in changes, and abrupt changes, acceleration type changes. This suite of instruments or capabilities that are coming online or are online can do some fantastic things that you can't do with current agency assets. I'm saying qualitative applications, that's not to be considered too much of a negative there, but you can, even if it is qualitative, even if you're looking at pictures of tanks and fields, that capability still allows you to do some very interesting things like detecting, monitoring, measuring abrupt changes, big changes in time and space. Like, for instance, in the Midwest, you have cornfields, in the spring, as you plow those fields, you get heavy rains, and suddenly in certain places you can have standing water. And if you've ever driven through these areas, sometimes you can have a lot of standing water, and sometimes you can have entire fields, huge, football size fields or bigger areas of standing water. Is that changing in time? Is that not changing in time with climate change? That information is tremendously valuable to people, for instance, down at the National Water Center in Tuscaloosa. So even if you're simply seeing water or no water in places where you expect land, that's valuable information. Find temporal and spatial scale problems, roughly calling these census challenges, because government's looking at doing sort of what they call methane census of creating a baseline measurement over things like gas fields and oil rigs and gas pipelines, and looking for changes because there's been a leak or there's some kind of an effluent that they weren't expecting. Counting up these places and doing that detection and monitoring. This is something that these very fine resolution sensors can easily do. And I talked about the methane sat. I think that's going to be a key contributor to this field. Global change indicators of environmental and societal impacts. Again, Betsy talked to this a little bit. It's not just the state variable, it's the impact of the state variable, which could be like the erosion on the beach or something like that. These are important indicators. There's great interest. They're used by public, they're used by government for policy, and they're used by industry, insurance and reinsurance, just one industry, of knowing what these impacts are due to climate change. And then I just list some there that sort of first came to mind, measuring glaciers and speeds of glaciers or glacier loss, wetlands. How much of the year are they wet? How much of the year are they relatively dry? Are they growing? Are they expanding or decreasing? These are typically not things you can measure with a VIIRS or a MODIS type sensor. Landsat, yes, but to even get finer information than Landsat or more frequent, again, you can use these commercial assets. Coastal erosion, inundation, nuisance flooding, those sorts of things. You can easily do that with this class of sensors. Standing water in fields, I talked to that. Wildfires, yes, we can see wildfires with the bigger sensors. Landsat typically sees them and can do a very good characterization of the fire scars, but the temporal sampling isn't there to look at day-by-day changes, particularly if you're interested in doing things like what are the emissions, as the emissions from this large fire change over the days and weeks and sometimes months that the fire's in progress. You probably need finer, higher resolution than what Landsat can offer. Land cover management. So I'm not talking about land cover. I'm not talking about land cover change. I'm talking about the management practices that are used with it. And if you talk to the carbon modeling community, they need that information to better estimate both the top-down and the bottom-up methods of figuring out fluxes and moving, assessing progress towards net zero emission fluxes. So it's the management practices I think that some of these sensors would be very good at. And I already talked about the greenhouse gas leaks, for instance, around oil and energy production systems. And then the last thing, I'll be very brief here because Chris just went through it. These hybrid constellations, can we do this? Thank you for explaining what an anchor tenancy is. I didn't know what that was, and I appreciate you explaining that. But again, it's a public-private partnership, putting a very expensive, high-quality gold standard in space and allowing you to not pay as much for a constellation of smaller, faster, cheaper sensors, but ensuring that there's some sort of tethering going on. I think it's a very compelling idea. So I just throw this up there. Hopefully that sparks some debate. I'll pass off to Daniel now, and I think he will moderate our discussion.
Great, thanks, Jeff. And why don't we just leave that slide up because it's a good, probably a useful item, right? Some people might want to come back to it. I'm a couple people who raised their hand, and Parag, even though I think he might have left already, did pose a couple of questions in the chat that weren't answered yet. And so I think one question Parag had was, what fraction of the current players in the NGO space, actually, sorry, let me just read it. What percentage are government, national, NGO users as part of the overall customer base for these companies? I guess, do we have an assessment of this the private sector companies and what fraction of their customer base comes from different parts, right, of the
government,
of the space? I guess government and or private sector. We know anything about that? I don't know if anybody's done that analysis. So
it's Parag, Daniel. I'm still here.
Yeah, go ahead.
In case the question was confusing, I'm sorry. First of all, I'm Parag Vaze. I'm at JPL. I've been working on a lot of the altimetry missions at JPL. So yeah, basically the question was, we're talking about this whole idea, which is fantastic, about leveraging, other privately available and produced data, but they're doing this, as everybody said, for commercial purposes. So is their business model based around selling the data back to government and NGO users, or is it primarily for other private customers? And this is a smaller fraction. So I was wondering what that was, and kind of related question, which was, it looks like people have already taken advantage of some of this, like the RO data that was just shown. So has somebody gone and actually done a cost benefit analysis of this approach for the data buys versus a more traditional approach?
Jeff, do you want to take a first stab? I can jump in with a couple of items. But
I really want, we just jump to you.
Okay, that's fine. So, I mean, I think first order, my take would be, right, it depends on the product, right? As far as your question of like, what customers, what fraction of a company's customers are either government or private or whatever. From what I've read, it's very dependent on the product, right? There are some interesting, maybe just like tidbits of info. I think when Dwayne and I and Betsy were talking with Kevin Murphy, he verbally indicated that NRO, for example, had just, committed roughly $1 billion a year for the next 10 years to what I would say kind of the electro-optical panchromatic, space portion of commercial space, right? So the Maxars, maybe the planets, folks like that, to kind of get data from them, right? So they want to make sure they have it seems like they want to make sure they have a steady stream of that data that they can rely on to complement their super high resolution, right? Self-owned spacecraft, and they're putting a lot of money down. And so I don't know the specifics. I would guess that like a lot of maybe Maxar's revenue is coming from that particular sector of the government. And I think the rest, I don't know. I don't know if anybody else on the panel happens to know, if there's some specific interesting examples like Spire, right? What fraction of their business base might be coming from government versus private? If anybody happens to know, maybe you can just jump in and say something. If not, I think it's just a question mark.
This is Dallas Masters again. I can speak a little bit to this, but I'm not going to speak to Spire's business. But what I would say is that it depends on the variable that we're talking about. I think RO is actually a very good example. RO is one where the end user of RO data sets are government customers, because very few other customers know how to deal with RO data. So I think that it totally depends on the variable we're talking about. If somebody's measuring soil moisture, that might be interesting to a government customer, but it could also definitely be interesting to a commercial entity like an insurance company. And so the business models that these companies have and the satellite companies that are producing these data will be dependent upon that customer base. If I think that it's perfectly viable to have a satellite company whose customers are government customers, and the satellite company can produce data less expensively than a government program could, and that satellite company potentially wouldn't even have any commercial customers for its data sets. But definitely there's different business models, and I think it depends on the variable that we're talking about at the time.
Okay, yeah, it totally makes sense, Dallas. It's Parag. It just, what I was getting at is there's by the way, I'm very new to this, so I'm really sorry for the naive questions. But my point was, if it's mostly a government customer, it just becomes a different way of contracting, where you're just contracting for a service instead of contracting for a satellite development, right? Versus there's already data out there that other people are doing, and we're actually leveraging and maximizing the utility of it, right?
That's correct. And I think that there's some really good examples out there of data that was produced by a company, and it turned out that the data were actually a very interesting climate variable or Earth observation. But the initial work to do that was not necessarily targeted for that, or it wasn't known that the data were going to be used for that prior to the company launching those satellites.
Great. Okay. Hey, Daniel, is it okay if I ask my other question? Because I got to jump off, or I'm sorry.
Sure. Yeah, go for it.
Okay. My other question was a very interesting discussion earlier about the science, CalVal, and validation by other methods, independent methods. My question was, I'm familiar with NASA. So we at NASA, there's a huge program for in any project for all of the science and CalVal and independent validation, which seemed really important from the user perspective or NASA perspective, but also maybe from a commercial perspective. I think, Dallas, you were saying earlier that this is something commercial companies are interested in, and actually getting that validation, that quality seal. So my question was, it seems very symbiotic, and is there a different business model where NASA, or let's say agencies, actually provide the science and CalVal as opposed to and partnering with commercial as opposed to the data buy for that particular agency? That was my question. I'll stop there.
Striker from USGS, Parag. That was a very good question. I might just jump in because
whoever's answering right now is really faint. I don't know, Tim or Timothy, if you can maybe get closer to your mic.
Can you hear me better now?
A little bit.
Little bit? Okay. Sorry about that. How about this?
That's better.
Okay. All right. Yeah, apologies to jump in. I did have some other comments on these wonderful presentations, but in response to the comments just made, there are different mechanisms for that type of dialogue and calibration and validation of data between government and commercial agencies. Again, I don't know much about this anymore. I know on the kind of weather satellite, atmospheric satellite side, there was the Global Space-Based Center Calibration group that I think was associated with the committee, the Coordination Group on Meteorological Satellites involving NOAA, I believe NASA also. And on the terrestrial side, there's the Joint Agencies Commercial Imagery Evaluation group that involves USGS and USDA and NGA, I believe NOAA and NASA also. And there's a lot of exchange, a lot of work with those those various companies. I know at least on JC, because there are a lot of commercial land imagery ventures to review and assess and validate and share results with those companies about their data. And it's been a very productive relationship. It's now been replicated in Europe under a group called VH-Rhoda. And so that is a very good, kind of very good dialogue and starting point. And it does kind of reflect, I think, what Chris had spoken about earlier with GPM and precipitation validation against a gold standard. If you're looking at Landsat or maybe to a lesser extent now Sentinel-2 data, the calibration and precision, long-term continuity of that data is extremely helpful in working with the commercial companies to make adjustments to their data so that we can all better use that data. But I think it does also call into question, even as commercial firms advance and technology advances generally, thinking GPM or follow-on missions or Landsat or follow-on missions, I think there still does need to be some very high-level gold standard that's going to involve probably more investment and investment in time and personnel and effort on behalf of governments than I think private companies usually are willing to make on those types of things. But I would agree there's certainly very much a symbiotic relationship there, synergistic relationship between industry and government that we need to look into. Thank you.
Thanks. Okay, we're going to transition a little bit. So it is 1:30 Pacific time. This is going to 2 o'clock Pacific time. I think we're going to let conversation go to for this next section, which is just pure moderated conversation. I'm going to hand it off to Rashmi. And I think we're going to try to wrap roughly 1:55 Pacific time, so about 27 minutes or so. So Rashmi, why don't you take over?
Thanks, Daniel. And since there's still some hand raised, we'll probably just start with the hand raised. So Charlie, you're next.
Hi there. Yeah, so it's Charlie Powell from NOAA and also from the University of Michigan. A couple points on this last topic, but it's sort of, I'll try to tie it back to the sort of point of this discussion as a whole. One of the things that, the charge of this KISS workshop is going to be continuity. And one of the things that I'd like to refer to in some of the performance metrics that we're talking about is not just the performance of individual sensors and making sure the sensors are calibrated and stable, but that the performance of the constellation and the observation is stable in perpetuity. And so one of the things, for that might be useful and advantageous to hybrid satellites is, the fact that it's resilient and that you can regenerate it, and, there's shorter development timelines, and it sort of breaks us away from the extremely fragile and brittle architecture that a lot of our climate observatories have now. Any one of our climate observatories could have a launch failure like TROPICS did or OCO did, and any one of them could, it's sort of miraculous how long some of them have been living up there right now. And so, planning around resilience as a performance metric and not just sort of radiant stability, I think is important. The second thing is note is that on the sort of concept of sort of architectural resilience for continuous observations, as we start thinking about commercial options, is also the viability of business models. So one of the things that I would think about if I'm buying sort of long-term observations is how viable is the business model of my vendor, because I don't want to get into a monopoly or a monopsony situation where I get vendor lock and the prices are going to jump 400% next year. I'm interested in making sure that if I'm purchasing data that might be meeting other performance requirements and give me other sort of performance characteristics, will still be in the best interest of taxpayers. And so, how do we evaluate the sort of overall business case, constellation case, and sensor case for each one of these sort of observables, and sort of, trying to generalize along that?
That's a very good point. Does anybody want to address that? Or have any comments on the last portion of what Charlie mentioned?
Yeah, this is Chris. I'll just mention the issue about the long-term viability of a company you're relying on was one of the main impetuses in this National Academies report for the idea of anchor tenancy as a way to give those companies some stability with a long-term customer that likely going to be there.
This is Dallas Masters from UN Space. I can also speak to Charlie's question and sort of segue into actually what I was going to bring up when my hand was raised. The long-term stability, stability of a company rests a lot of times too on whether that company knows that there's a desire for that measurement or that variable for the long term. And if they enter into a contract and they know that there's going to be a request for those data sets for the next 25 years, that's much different than if they signed up to do a one-off satellite mission. And I actually think that New Space would be a very good model for sustainable observations for climate. And the reason why is because I think NASA does a very good job of producing Pathfinder missions and showing how we can make measurements. And I think New Space is a very good opportunity to pick up those technologies and then fly them for the long term on sustainable constellations, because the prices are so much cheaper to do it with, say, New Space models. I think we actually do a very poor job of actually sustaining any of the climate variables that we're trying to measure. I think there's a few examples of those. GRACE is a great observation. Mass change is a great observation. We know we need to continue measuring it, but I don't think we have a very good model for how we're going to do that in the future, because GRACE, the technology behind GRACE is pretty expensive. But if we could come up with models or different technologies and instruments that could be passed to New Space, and then have contracting vehicles where we want a New Space company to continue that measurement in the future for the next 20 years, that's definitely a good business model for a company to pursue. But I don't think we have the contracting vehicles in place or the ideas to do that. The idea that NASA does Pathfinders and, say, NOAA picks up those technologies and then flies them operationally. Imagine there's New Space that's picking up those technologies and doing it as well on behalf of the government, because we know we need to make these climate measurements for the long term. So I think New Space actually has a very good niche here to solve these problems about sustainable observations. And the idea to have constellations which we are being replenished constantly, that is the New Space model, right? And if you need 20 satellites all the time, a New Space model is that they can always be replenished. And that's much different than flying billion-dollar Pathfinder missions and then getting hooked on the climate variable that it's measuring, but then having no way to sustain that in the future. So just wanted to make those comments.
Can I push back on that a little bit, or maybe ask for clarity?
Sure.
In line here. So
Go ahead.
What's the different model there other than going to smaller buses? You're right. I mean, we have NASA, which is innovation and demonstration, showing the technology works, and then doesn't always happen quickly, but NOAA is to be the sustained requirement. So there's supposed to be an R2O process. But I think we've already said that the government would need to be involved sort of in this anchor tenancy thing, or as a primary source, if for no other reason than to keep the company viable, particularly when we're talking about climate observation. So some government entity, is what I'm saying, has to let the contract to what we call New Space. Before that was also happening, there was a program. In either case, it's going to be a program, whether it's called POSE or JPSS, or whether it's called NOAA Commercial Program Office, of making investments into the private sector to get the things built, launched, and operated. What really is the difference? You said we could hand it off to New Space, but we really can't hand it off to New Space, right? We still have to have the government as a role in providing that contract to make sure all the measurements are done, the requirements are in place. The climate community can't just sort of say, and the climate community wants this.
Oh, no. Yeah. If you came across with the idea differently, then I misspoke, because I agree with you completely. What I'm saying is that if there was a climate variable that we needed measured, and we need to have a long-term sustainable flow of those types of data, New Space companies could fly small sat constellations to produce that data and do it under a government contract. I'm not saying that New Space companies, you hand it off and somehow the New Space companies are doing it outside of the government contract. I'm saying that they would take up the position of flying some type of sensor that could do mass change on a small sat constellation, and that would be the way we sustain mass change measurements for the indefinite future. But it's a government contract. It's definitely, the government says we need this measured, and we're willing to have a small sat company produce that measurement for the next 20 years. And I don't know how competition would work in that, because like what you're saying is where we want to have sustainable measurements that are always the same. So maybe you're always going back to the same vendor. That's not a very good model. You do want to have competition. So maybe you do have, 2 or 3 companies that are producing these data sets, but it's no longer that you have to hand it off to NOAA to do it. You have other companies that can do it as well.
Very good. Thanks.
Did I clarify that, Jeff?
Yep.
Okay.
I think that's good. Thank you.
Thanks, Dallas. And I think you were segueing to the question next, since your hand is raised next.
Well, I actually was just making a comment that I think that there are models that new space companies can fit here. The idea to, like, I think Chris brought up something like flying demo missions. New space companies are perfectly willing to fly demonstration missions, especially say you have a sensor that is measuring a climate variable, but it's a large sensor on a Pathfinder mission, but there's new technology that can miniaturize that. New space companies obviously fly smaller satellites, but if there's a transition to those smaller sensors and then a path to building constellations that would carry those, demo missions are perfectly reasonable types of things for new space companies to do as well. If NASA flies a new sensor, new space companies like mine are looking at those new sensors and wondering if we can somehow fit those onto our satellites, miniaturize them, and turn them into sustainable products rather than just Pathfinder missions. I think that we do a great job of building Pathfinder missions, and we do a horrible job of sustaining those measurements going forward. And I think New Space is here to help try to do that.
All right. Thank you for that comment. The next question or comment is from Timothy Stryker. Tim? Tim, you're muted.
Oh, I'm sorry. I had forgotten to lower my hand from before. So
Okay, no problem.
Thank you.
Legacy hands are quite common. And then Eric.
Thanks, Rashmi. I guess one thing that seems to me to be a kind of a common theme in conversations that I've had around the government about commercial data is, what is the business model of the private sector? But it seems to me as though, what I really haven't heard a lot of is what is the business model of the public sector? Because it seems to me as though a lot of the confusion, first of all, there's a confusion about, okay, well, if you're the public sector, then, what goods and services are you trying to provide? And, it does seem to me as though when I've seen the government, when NOAA purchases this data, they're purchasing it as an input to a weather forecast, no differently than if they're purchasing, staples and office supplies or something like that. That never has mattered before. We've never had to think about this issue because the satellites were always all-purpose satellites and they were always launched within the government. But now we actually do have to have this conversation about what service are we trying to provide. And it seems to me as though if you don't do that, if we always think, well, the private sector has these and that, this need and that need, we're really not getting at this fundamental question, because it seems to me that really the problem is, nobody in the government is really on top of climate observing. My agency, the National Science Foundation, we don't want it. We really just do 3-year awards to people in academia. NASA doesn't necessarily want it either, because NASA is all about the next big thing, being on the bleeding edge, things like that. NOAA does have NCEI. It does have kind of ownership of climate. But really, if you look at NOAA, if you look at sort of the reward and punishment system that NOAA lives in, it's all about the 5-day forecast. I mean, if you bust the forecast for Hurricane Sandy, you get dragged down to Congress and all the rest of it, And so I think the fact that there isn't a strong desire for ownership of the climate problem within the government really makes it difficult to have these conversations about what's the best way to provide the observations. You know, one of the things that I think, you know, we could be talking about in terms of, you know, this business of, you know, what's the best way to provide climate services and things like that. You know, well, there's the tenancy argument. There's also, I think, a good argument for, you know, what in radio occultation world is called the backbone constellation. You know, that constellation that's always there. That's a government funded thing. But you know, whereas I can have any number of conversations about the backbone constellation with people who are interested in this issue, I don't think that resonates at the highest levels of NOAA. You know, I think at the higher levels of NOAA, there's much more of a desire to be receptive to Congress, and Congress is very much driven by the commercial sector. You know, so I think, you know, one of the things that really ought to be part of this conversation is, you know, how will the government get together and figure out what it really wants to do about climate observing? Because until you've done that, I think all of the conversations that we have, they're liable to be a bit piecemeal, and they're also liable to be a bit speculative, you know, in terms of, you know, the things that people say versus the things that may be politically possible. But maybe I'll leave it there. Thanks.
Thanks, Eric. I think you have generated quite a few hands, so I'm going to call upon Charlie next to comment.
Yeah, no, Eric, that's a great point. And I think it's the essential one because, as you know, sort of NOAA owns, you know, a lot of the observations for the 5 to 7 day weather forecast, but a lot of the climate observations, the ones that are useful really for future climate services or orphan projects, one-offs from NASA that really don't have a home. And that's a good question that I don't have an answer to. I will say, though, that NESDIS does have an answer to how it views itself in sort of the provisioner of data. And it's really, we're data agnostic and source agnostic. You know, we are in the, you know, we want to provide, you know, authoritative data sets for consumers. And the problem really is, you know, is what exactly are the observations and product lines we're responsible for. And right now,
but let's go back to that point, because when you say you're data agnostic, you know, I read that in a very specific way. I read that as saying that the source of the data doesn't matter, right? That the goal is to provide this data, and if you can get better data by buying it than you can by launching your own satellite, then you go with buying. The problem is that hasn't actually happened. When you buy the data, it comes with license restrictions, and when you launch the satellite yourself, it does not. And even under the most sort of, you know, open license that NOAA has purchased, you can't share that data with ECMWF and UKMO, which are the best centers in the world for processing and using the RO data. They have been world leading. You know, and so I think that difference needs to be resolved if you really want to say that you're data agnostic.
Eric, you make a totally valid point. And in the latest NOAA science plan, strategic plan that came out 2 days ago, we do advocaatly, forcefully message our interest in promoting open data policies. Notwithstanding the fact, we want to be aware and create space for commercial innovation. And I think the idea, you know, in the current RO contracts that we've let, you know, we do have redistribution rights specified with certain centers and with certain consumer bases, particularly within the US government. And we want to create opportunities for other purchasers to offset the cost of that, including the European Center for some of those data rights. And so, you know, I think, you know, for what it's worth, there's, you know, opportunity space to sort of meet NOAA's requirements, which are to, you know, promote national security, public safety, and produce a really, really good 5 to 7 day weather forecast, and also any other climate observables at the best value of taxpayer dollars. And whatever data meets that for us at the best value, that's their going rate.
But, you know, sorting out those contradictions has got to be part of the conversation. You know, that would be, you know, my only kind of comment is that, you know, when you list the things that you're doing, they don't necessarily play nice with each other.
So with that in mind, there's a couple more hands raised, and I think everybody would like to hear from people whose hands are raised. Jack, would you like to comment on it?
Sure. This may have been mentioned and I may have missed it, but you know, one of the things that I think about with this is as we talk increasingly about you know, more openness, and whether it's, you know, transition to open source science or, you know, open source science in general, the idea that you know, everything is supposed to be open, and you know, you have a satellite, the algorithms are are open and things. So, and my understanding on commercial things is there's always a sense that some things may be proprietary. Now, I understand that there's always a sense that everything's subject to negotiation, but it does seem like, and I apologize if this was discussed and I missed it and got distracted periodically. That there's a certain inherent, tension may not be the right word, but the push for everything being open and transparent to commercial things having proprietary interests. It seems like that's something that's going to have to be navigated.
Thank you. And Jack, since you were speaking for the first time, would you mind introducing yourself for the group?
Oh, Jack Hay, Associate Director for Research, Earth Science Division at NASA headquarters.
Thank you. Okay, next we have Chris.
Yeah, thanks. I wanted to, I mean, I'm not a billionaire. It'd be nice if I was a billionaire, but I'm going to sort of pretend that I'm a billionaire and just try to put myself in the place of the investors that are funding these new space companies. I think, there's a whole bunch of them now. There's a lot more than there were, 5 years ago or 10 years ago. And there's people who I assume are really smart because they're really rich, but maybe not. But, there's people with a lot of money. They're investing in these companies because they think that there's something to invest in and there's a future in this. And, in terms of earth science related things to invest in, I guess weather forecasting is one, but I mean, there's always been a need for weather forecasting. I think the thing that's changed in terms of the likelihood of future needs is, climate change and, the, growth of extreme weather events and more flooding and more fires and more need to reconfigure our energy infrastructure with wind and solar and just all these things that are going to happen in the future. And there's probably a lot of, money to be made. And it's this huge business thing that's going to change a lot of what we do in the next 20 years. And I'm guessing that's why they're investing. And I think that it's really, incumbent on the government to figure out how to deal with it. If NASA isn't leading the charge for, continuity environmental monitoring, or NOAA isn't, or USGS isn't, I mean, somebody should, or some consortium should, or something. And there's a comment here from Jeff that we should think about this in the KISS study. I think this is a great topic to address in this KISS study that's coming up this fall. And if anybody in the audience now who isn't on the KISS panel has ideas about it, it would be great for them to send it in to Jeff or me or Dwayne, who's kind of running this thing, and with suggestions about ways that we could, try to structure the way the government is going to deal with this if it's not structured properly today.
Thank you, Chris. And just for everybody's reminder, this was mentioned by Daniel at the beginning, but the goal of the KISS study is to really accelerate in the discussions and plans for greater and more impactful U.S. contributions to the global climate observing system. So how are we going to do it is definitely within the realm of that. All right. I have one more hand raised, and that's Dallas. And in the interest of time, go ahead.
Sure. I just wanted to address some of Jack's concerns about like the proprietary data or the proprietary information that companies might have and how you navigate that. And sometimes that can be addressed with some of the ideas behind sort of like the purchasing of level 0 data. So, if we're worried about what is happening in sort of a data product processing system that a company owns, You can go back and say, well, I want to buy the raw data output of a sensor, and that's what's in the contract, and therefore, as long as the customer, the government, is comfortable with the data coming out of a sensor, then they can do whatever they want with it. And there's still a viable business model there for the company, because they're selling you the data, that a level 0 data, and it allows the NASA to produce whatever it wants, or NOAA to produce whatever it wants from that. Now, if NOAA and NASA produce, say, like a soil moisture product from those data, and they release that soil moisture product to the world, then they would be basically precluding the company from making a soil moisture product as well. Or the company would have to compete with it and make a different soil moisture product. But I think that the business model is still there. It just means that the company would have to understand that the level 0 data would be sold at a higher price, because there's no other opportunity for the company to make a profit on some derivative, because the level 0 data has been released to the world. And I think that those are just different business models, and they come with different pricing concerns for the companies involved. If that gives you some idea of how companies view these types of things.
Stars. Hey, Jack said thanks. All right. In interest of time, I think I'm going to try to wrap this, and I wanted to wrap this session with just a question that you can answer by raising your hand or not raising your hand. And this is just based on what you've heard today. Do you think the NGOs can or should play a role in global climate observing system? Just based on what you've heard today. All right, I see a lot of hands raised. There's quite a bit of
Would you
people who are-
consider asking the opposite question? Because I think some people might have walked away from their computers. I think
Yes,
this was, yeah.
I think that's a good point. So now that we have seen, let's ask the other questions. If everybody can lower their hand, and then I can ask the opposite question, is based on what you heard today, do you think NGOs should not play a role in global climate observing system? All right.
Looks like the ayes have it.
Yep. All right. Thank you, everyone. I'm going to hand it back to Daniel to sort of wrap it up.
Thanks, Rashmi, and thanks, everybody. That was a really great, I think, 3 hours, a lot of good conversations, good presentations. I just wanted to, again, thank the presenters who spent a lot of time over the last few weeks putting that material together. And literally today, I think, as I mentioned at the beginning, are like globe spanning. We have Rashmi in the Eastern Pacific and Indonesia, a lot of us in the US, and Betsy in, no, I guess it's Geneva now, but Central Europe. So the fact that we were actually able to pull off this mini symposium is in large part thanks to their sacrifices, their time, and Jeff is on vacation. Right, so it was really important for us to get this done ahead of the KISS study in mid-August. So we appreciate everybody's sacrifices. And again, same thing for all the participants. I know it's kind of late on a Friday, so thank you for hanging out and engaging so thoroughly in the conversation. It was really useful for us. And then just a reminder that the links that we had in the introductory slides, and maybe Wingsei can post them again into the chat. You can see a recording of the material there. I believe we will also provide links to the slides themselves once we have kind of the final versions in Wingsei's hands, and we'll make that available to folks. And I think that's all I had. So thank you again, everybody. Any closing remarks from Dwayne or Betsy or anybody else? on team?
Daniel, this was so useful. Thank you very, very much for all the work you did.
Yeah, you and the whole team and the support staff, it was excellent. I just wanted to bring attention to Eric's question, which I think was a good one. And there was that we have submitted an abstract to the Darmstadt conference based on whatever outcomes we have at the time from the KISS study. So we're hoping that there'll be a forum of people really interested in picking up in that conversation there.
And this is Chris. Daniel, I was going to ask, can you capture all these chats and put a little
I did.
document together? You did? Okay, great. Great.
Yeah.
Yeah, I think so. Rashmi and I were chatting. So WebEx actually takes a transcript of the verbal conversation. It's got a pretty decent kind of captioning capability. And Wingsay or Margaret, maybe are you guys going to save the chat, or do I need to specifically do that?
I just did. Okay.
Okay.
Yep, I
Yeah.
already saved it.
Okay. Beautiful. Thank you so much, Wingsay and Margaret, for making all this happen as well.
Thank you.
Okay, I think with that, we are done. So have a great rest of your Friday, wherever you are, and weekend. Thanks for all your help.
Thank you. Bye-bye.
Yeah, this was excellent. Thanks.
Yep. Take care, everybody.
Thanks very much.
Thank you. Bye-bye.